That's, Am I going crazy or did they move it?
Well, we are recording now, so.
Okay, that's good. Yeah, I see it's on yours. I just don't remember. I thought it was in the little 3 buttons.
Yeah, it is.
It is for you?
Mm-hmm.
Huh.
Yeah.
I don't see it. Wow, that's weird. Okay, I guess I'm not going crazy. Skype is going crazy. Okay. Anyway, all right.
Let's see.
So
an alternative app to this. It's open source. You can also record.
Oh, what's that? What's a good alternative?
Jitsi, Jitsi, I think.
Oh yeah. Okay. Yeah, maybe I'll try that because Skype, not only is it acting weird now, but in the past, it has this tendency to over compress my audio for some reason, or it's probably some setting I'm not setting correctly on my end, but it tends to like really distort it, and it would be nice to have an alternative. But it has this, the reason I use it is because it has that built-in recording feature, which is kind of nice.
Yeah, but if the servers are messing up, you don't want to rely on that. It'll probably be fine, so we'll just do it in Skype for now.
Yeah, well, this will work for now, but yeah, I'll check out was it Jitsi or Jits?
Jitsi. Yeah,
Jitsi.
Jitsi, I think.
Okay.
Yeah, so anyway, we were discussing in comments of your new theism video the orthodox argument that Jay Dyer has often used and other theists have used, where God provides a kind of foundation for certain kinds of truth, like logical truth, mathematical truth, that's emphasized, but truth claims of all sorts, also, they see God as providing a firmer foundation for those sorts of things, because then there's a place for the meaning of propositions to exist outside of just human brains and outside of particular states of affairs. It allows you to basically have a referent for propositional knowledge regarding counterfactual scenarios, possibilities. You don't run into the same issues if you use this argument that you do in more like materialist or realist accounts of truth, where like what is the bearer of truth. So that's what I was originally trying to convey, just that the emphasis of the argument is not so much that you need God to be able to have certainty, it's that it's a kind of theoretical postulate that allows propositions to subsist somewhere. Like, where is the truth value of propositions? Is it only in our heads? Is it so if it's in God's mind, that provides a kind of easy answer there. And we went back and forth. I don't quite remember how the exchange went, but where do you see me going wrong in addressing the issue of mathematical truth? You seemed like you were collapsing it back down into empirical truth. You were saying mathematical truth is inductive. I'm not sure if I completely follow you there. It seems like there is some kind of distinction between mathematical knowledge and empirical knowledge.
Well, there is, but we have to understand what we're talking about when we talk about mathematics or any formal system like formal logic, that what we're talking about is a human creation, analogous to a language or the game of chess or a system of laws. And things are true with respect to that system. So a truth of mathematics is a truth of mathematics. And what makes it true or false is whether or not it can be derived by the operations, the methods of inference that are valid in mathematics from the axioms of mathematics. So in other words, if we have a way of demonstrating that it is a valid theorem of mathematics, then it is a mathematical truth. And I think there's a confusion that arises between formal languages and innate mental processes. Like, we should not confuse formal logic like, Boolean algebra, whatever, propositional calculus, with the innate knowledge that we are born with that structures the way we construct, models of the world and the way we think. Those are different things. We can one reflects the other, or at least one reflects some aspects of the other. Logic is something that we created to reflect the way that we think. But we shouldn't confuse formal logic with the logic that's built into our brains, or mathematics with our innate, the innate properties of the brain that make us see the world in a certain way and think in a certain way. And a proposition such as 6 is not a prime number is a statement within that system of mathematics. It's not, I don't know what else to say about it, really.
Mm-hmm.
But that's an important distinction, that we don't confuse formal languages with mental processes, even if the formal language was designed to reflect mental processes. It's still not the same thing, and a statement of the formal language is not the same thing as well, let me put it this way. We don't like the sense in which a statement in the formal language is inductive is that you have to learn the system of mathematics, right? If a baby doesn't have the sentence 6 is a prime number in its head, or 6 is not a prime number in its head, right? A baby doesn't have any sentences in its head. It has to learn a language. A baby doesn't have any notion of number. It might have the ability to distinguish two different objects of the same type. And so in that sense, it has some kind of, the innate properties of the brain that make mathematics possible. But it doesn't have a notion of addition or subtraction or multiplication. So the baby has no innate, no a priori knowledge about what is a prime number. The baby has to grow up, it has to learn language, it has to learn mathematics, and only then can you pose the question to it, is 6 a prime number? And then to answer the question, it will use the knowledge that it has acquired inductively, like from experience, about the system of mathematics to answer the question, right? So now within the system of mathematics, whether a number is prime or not is determined deductively. But the system itself is learned inductively, and it is applied essentially inductively, in that we have to experience the process of deriving the theorem to know that it is a theorem.
Right.
Okay,
I
so
would
that's
just, at that point, we need to clarify this issue of inductive learning when it comes to mathematics. I mean, Kant would treat mathematical sentences as synthetic a priori, meaning it does take time. There are mental operations that have to be carried out in order to gain that knowledge of the given mathematical sentence. But the entities that we're dealing with are not derived from experience.
and I think this is where Kant is wrong. I mean, this is this is probably his biggest error.
Where do you find the number 3?
You
Where do
learn
you
the number
find
3,
the
you're
number
taught it.
Oh, okay. So how is it that someone is taught the number 3?
Well, you learn how to count, right? You're taught to count. As a baby, as a little child, they teach you 1, 2, 3, and they teach you the operation of counting, which is an operation of placing number tokens into association with objects. And then later you learn other more abstract notions of number, right? Like a kid will say, what is the biggest number? And that's a perfectly valid question for a child to ask. And it's only later that as you grow up and you expand your mathematical knowledge that you understand, oh, there is no biggest number.
Right.
But you have to learn that.
Going back, though, you're saying this process of teaching the child to count, countability is already built into our cognitive modalities, just like you're saying certain logical operations are. And so that's what Kant means by saying that mathematical truths are often.
Well, this is where he goes wrong, though. But this is where he goes wrong. He's not making a distinction between a proposition, a statement, and some that is within a formal system, that a child has to learn, and a mental process, like the ability to distinguish two objects as separate objects, but being of the same type, is an innate mental ability. But the ability to answer the question, is 6 a prime number, is an acquired ability.
Right, but the way that you acquire it is by being led to the appropriate synthetic a priori processes. You have to deal with
I
your
think
own
this is not
intuition.
true. I don't
No,
agree.
in order to discover how to deductively, reason mathematically, you have to be introduced to the intuitions that mathematics relies on at base. I mean, how did the first mathematician ever come up with the idea of numbers? It had to be built into the way that we think.
Well, it
Right? So you have
is,
to
right,
be
it
led into a
is.
position where you can conduct these a priori processes, but you're not taking things literally from experience and manipulating those things from experience.
No,
Experience leads you to recognize the intuitive structure that is already there in your mind.
well, okay, so again, there's a distinction between the formal language or the formal system of mathematics, which is conducted consciously outside of our, in fact, often on paper, right? We learn operations that are carried out on paper, not inside our minds. Operations that our minds are not even capable of. Like your mind can't divide big numbers. And yes, the processes, the steps, are based on innate mental abilities, like the ability to distinguish two objects of the same type, or the ability to associate tokens with objects, right? So we have this innate mental stuff, but that knowledge, that innate knowledge, is not propositional. It is performative. It is just there. We do it. We don't have it in a set of propositions. We just have it in that when you see 3 sheep in a field, you distinguish distinct sheep. So 3 objects of the same type. So that's innate. But the system of mathematics, which involves using these tokens called numbers to track these objects and then manipulate the numbers in certain ways to arrive at conclusions and all that, that's something we invented. And the explicit propositions of mathematics are sentences within a formal language that we designed, in the same way that chess games are sentences of chess. Like we can define the rules of chess, and then that defines a space of possible chess games. We define the rules of mathematics, and that defines a space of mathematical theorems.
Right.
Okay,
So there's a few issues here. First, when it comes to laying down axioms for mathematical systems, it's obviously not entirely arbitrary. There are constraints on the kinds of axioms that
of
work.
course,
Same,
of course.
yeah. Okay, and
I'm not denying that.
where
Right.
does that constraint on the arbitrariness of mathematics come from in your view? Is it those innate mental operations?
Right, exactly, right.
And is
Just like
that why you would say that mathematics is effective in describing the world, because we're mapping our own logical processing, and that processing evolved to survive in this world, and therefore mathematics, which is a representation of our brain, works to describe the world as well? Is that what you would say?
Sort of. I mean, to some extent, it's the anthropic principle. Like, if mathematics wasn't an effective way of reasoning about the world, let's say it was like astrology, then we wouldn't use it to reason about the world. So, we have developed ways of reasoning that extend our mental abilities outside our brains. Mathematics is one of those things, because we have very limited short-term memory, and we have actually a very limited ability to do math in our heads, as anybody who's tried to do it knows, right? So what we've done is we've designed something that we find, like each operation, we find intuitively valid. But then we can carry out a series of complex operations outside of our heads that we can't do inside our heads. Like even just keeping track of the number of sheep you have in a field. This was one of the earliest uses of tokens. You put pebbles in a gourd or something, and for each sheep, you would put a pebble in, and then you could, when they come back, from the field at night, you map the pebbles to the sheep to see if any are missing. That kind of operation. So we have learned culturally over a very long time, thousands of years, to do all these sorts of operations outside our heads and to use external representation systems, such as numbers, to represent reality. But of
Right.
course, the underlying basis of that is our innate ability to represent reality, right? But then the
Right.
other thing is that also it is partly the anthropic principle. Like if it didn't work, we wouldn't use it. So the incredible success of mathematics in explaining reality is kind of like it's
Right.
just sort of
That raises the fundamental question about which mathematical systems would work, right? You're kind of appealing to that this particular kind of mathematical reasoning evolved culturally because it worked. But what you're basically saying then is that there was a probability space, a space of potentials before we defined our mathematical systems, and that probability space had a range of values for mathematical systems that went from more useful to less useful. So the question is, we can discover somehow useful mathematical systems. The systems that are useful, that apply to reality, would those have been useful and applicable to any potential species that was capable of mathematical reasoning, right? Would it have been possible to invent a valid system of reasoning? Would it have been possible at the outset to have developed an inapplicable system of reasoning? And if that distinction was real, then it doesn't matter that in actual fact we did develop mathematical languages. The point is that there were available mathematical operations that were, possible, and we found those ones that were possible, right? So how do you
well,
account for the existence of some languages being appropriate, some languages being inappropriate?
okay. So first of all, the key point here, though, that we started with is to distinguish the formal system from the innate mental abilities and not to conflate the two, which I think Kant probably does. Although I haven't really read Kant, so I don't know, maybe he doesn't, but I think he does because I get that impression from what people say. And we don't have any propositions in our heads a priori, nor do we have any ability to drive any proposition at all until we have experience. So that's an important point. Nobody sitting in a cave or whatever with no experience of culture or of the world is going to form a proposition. The brain does not have propositions in it. Like propositions are something that are uh, ideas that depend on background knowledge that is learned from experience. And that's true for mathematical propositions. That's true for something like there's milk in the fridge or the earth goes around the sun. So all of those things depend on experience. None of them can be derived prior to experience. So that's an important point. You may not agree with that, but that's
So
one of the points I'm making. So I just wanted to be clear.
I get what you're saying. The implication would be that things can only be true or false. A proposition can only be true or false to an individual, and that proposition has to be built up in their mind through
Mm,
development, right?
well, I
But
don't know what you're
question,
saying by true or false to an individual. I mean, we use the
I,
terms true
I
or
mean,
false.
where does the proposition exist? If it exists in the mind, then saying a given proposition is true is only ever saying it is true for this individual who has formulated this proposition. Because if the
Well, to the
proposition doesn't have an external existence beyond that individual, then it can't be universally true. It can only be true for that individual.
well, again, it depends on what you mean by true. So, but also when we're talking about formal systems, we're talking about propositions that are explicitly represented in language. So they
No,
exist
no, that's not
outside
the meaning
of
of the
the,
proposition is the meaning of a
well,
sentence.
the
So
meaning, okay,
you can translate a sentence into various languages, and they can all express the very same proposition. The proposition is an abstract entity. It's not a linguistic entity. It's the meaning that we interpret from a sentence.
fine, but then in what sense does that exist?
Well, in my view, it does have a Platonic existence. right? I hold to the realm of forms. Basically, all mathematical truths, geometrical truths exist eternally. Propositional
There is milk
truths
in the fridge. I can put that into a sentence. I can say that to my wife. She can say, "Oh no, there's no milk in the fridge. You're an idiot." I can say, "Yes, there is." So I mean, like, is that a Platonic? Does the proposition "there is milk in the fridge" exist in a Platonic realm, or are we just using representations, whether it's ideas in our minds or words, to represent something? I mean, I would
would say
say the
the
latter.
truth,
I don't think
the
we need to
truth of
posit some other realm of propositions.
right. Well, the problem when you don't posit that, first of all, the example with the milk in the fridge, that proposition would have a Platonic existence, but it would be relative to your experience, to the experience of your wife, to the details of each of your memories, right? So, like, there can be Platonic forms of the relation between mathematical entities. There can be Platonic forms of the relation between uh, souls and individual human beings and things. So all possible relations have truth, not only because we recognize relations relativistically, but also because these truths of the relations that objects, abstract or concrete, have to each other, those relations are all kind of contained in the set of all propositions that are true. And so, I mean, it seems kind
But
of
what is the
costly.
set, though? But what is the set of all true propositions?
That is the set of um, all true. What are you asking exactly? The set of all true propositions is kind of coextensive with the realm of forms, right? So the idea is like a triangle has these given properties, and uh, there are truths that can be said about that geometric identity algebraically, and the propositional meaning of the algebraic sentences that express meaning about those geometric entities exist in that set of all propositions that correctly describe the relations of these ultimate forms and everything which derive from them.
Yeah, but I'm saying, like, what is this set of propositions? I mean, other than reality itself. So here's my account of
Yeah, it would amount
there
to
is milk
reality.
in the fridge. Let me give my account of this without
Mm-hmm.
having to invoke any Platonic realm of forms. I have a brain. My wife has a similar kind of brain. We have similar sense organs. We have similar emotions. We have similar ways of interacting with the world. We have similar bodies. And we grew up in the same culture. So when I say there's milk in the fridge, because she grew up in a culture that speaks English and she grew up with milk and she grew up with fridges and all that stuff, her brain constructs a model. And then she can compare the model that I'm conveying to her with her own model of the way the world is. And she might have a model in which there's no milk in the fridge. Then she'll say that is a false statement. Well, she wouldn't say that, but she'd say no, because your son drank it all. Okay, so there's no Platonic realm of forms. There's a reality that we both partake of. We can both interact with, experience. We can both open the fridge, look inside, and we use representations in our heads and externally in language to convey or hold information about that reality, and to, in our heads, to reason about it, to predict things. Like if I believe there's milk in the fridge, that predicts that when I open the door of the fridge and look inside, I will see a container with milk. And if I pick it up, I will feel weight and hear a sloshing sound if I shake it. So I don't need to invoke a Platonic realm of forms. It's
Well,
just there are brains,
even in
and
that example,
brains.
we need to go back to the mathematics example because that's why I originally tried to direct the problem
Well,
there. Issue with the independent existence of propositions, kind of what bears truth in reality. Is it sentences? Is it our beliefs? Like, where exactly does truth reside? If you don't posit the independent existence of these abstract objects, propositions, then mathematical truth is going to be difficult. But like first, in this example with the
but is
milk and
that the
fridge,
case for chess?
is what not the case?
Well, I mean, is this, don't you have the same problem for chess, the game of chess? We invented the game of chess. So where
Yeah,
did the
chess is a kind of mathematical structure, and there are true moves in chess, false moves in chess. There are things you can do, can't do. And like, yeah, you could say that we arbitrarily came up with the set of rules in chess, but it's just like you can arbitrarily come up with a computer program. You can't decide whether it's computable or not. So the set of valid moves in any chess-like game is going to be, in a sense, already predetermined by the possibilities of the basic logic of the universe, not just of our minds. And that is ultimately where our minds get their a priori intuitions of counting and quantity. It is from the nature of reality itself. So I think just ascribing everything to the human brain runs into problems. But first, let's look at this example with the milk, because I don't want to go in a bunch of different directions. Let's try not to uh, go to too many different topics and actually resolve before we move on. With the milk, at the instant that you make the claim, there are probably an infinite set of additional propositions which could be said of the scenario that are either true or false. And I can entertain that. So, for example, it is true that BlitheringGenius said there is milk in the fridge. Outside of the truth value of the proposition, there is milk in the fridge itself. Or you could say it is false that BlitheringGenius said that there is no milk in the fridge. And then many other kind of meta propositions that can be said about the scenario. And as soon as I look into that space of possible things that can be said about the scenario, I can identify all sorts of possible true statements, possible false statements. And if it's all dependent on what's going on in our brain, then what you're ignoring is the issue of all those potential true propositions that if we said them would be true, and if we don't say them, they're not true. If propositions only ever exist in our mind, then how can it be said that there is this set of true propositions that could be said and this other set of false propositions that could be said? How do those all exist in potentia as potential true propositions? How can they be independent of our brain?
Well, I don't have this notion that there's some kind of brain independent truth or some set of true propositions that exists out there. In my account, there's no need for that. There are representations, and the representations are, I mean, truth is, the way we use it in ordinary language is kind of like the way we use a word like flat. Like, yeah, the wall is flat, the table is flat. But of course, if you look at the table or the wall in a special way, like through a microscope or whatever, well, it's bumpy as hell, right? I mean, so we use these terms in ordinary language, but when we're into philosophy or psychology, we have to start thinking about, I mean, the prior question is, what is meaning? What are we doing with our brains when we represent reality or talk about reality? And then we can, like, we have to understand that first, and then we can talk about what is truth. And I don't think truth is a correspondence between an idea in my head or an idea expressed in language and some set of true propositions that exists out there in some other realm. I think it has to do with whether or not that information is like predictive of something. Like it's about how it will affect. I mean, really, truth is a judgment that we make. We commit to using a certain model to represent reality and base our actions on that model. So, like, if there's milk in the fridge, then I don't buy it at the grocery store. But if there's no milk in the fridge, then I do buy it at the grocery store. Right? So I'm committing to one of those models when I make that decision. Right? So when we say this is true or this is false, what we're saying is, okay, for practical purposes, is this statement adequate for generating action, or will it generate confusion and surprise if I commit to it? Like, if I commit to believing there's milk in the fridge and I open the fridge door and there's no milk in the fridge, then I believe that I'm wrong. So we have
That's
this
limited conception of truth. I mean, it's similar to like a verificationist idea of truth, where truth is only that which can be kind of tested, right?
Well, I'm saying there really isn't truth in the sense that you want it to be, like some kind of objective truth. There are models, and the models work or they don't work. And that's why I brought up the epicycles. You know, like, were the epicycles of the Ptolemaic model of the solar system true or not? Is the model that everyone sees in a textbook true? The one where the Earth goes around the sun in a kind of circle or ellipse? I mean, is that true? It's, I mean, what does that mean, right? I mean, in a sense, it's true. It predicts what we observe, but viewed from the perspective of somebody who is, you know, in the Andromeda galaxy or whatever, some other perspective, the Earth is going, you know, around the Milky Way with the sun spiraling through space, not going around it in a circle. So, right? I mean, I think you're kind of begging the question that there is this notion of objective truth that is based on a correspondence between propositions that really exist and ideas in our head. And then you're saying, well, if you don't believe in a Platonic realm, then this notion of objective truth goes out the window. And I say, yes, it goes out the window. Yes. I mean, in ordinary life, we don't have to worry about those things because we're stuck in our little frames. We're stuck in a frame where, yeah, we don't have to worry about whether we're going around the Milky Way galaxy. But yeah, there is no objective truth. There are models that we construct from our perspectives and we use them. And some of them are so general, like 6 is a prime number, or so tied to something that doesn't change, like mathematics, that it seems objective to us. Or they're so tied, like we can verify them.
I get what you're saying. I mean, basically, it's a pragmatist theory of truth, and it runs into problems.
Well, it's not a pragmatist theory of truth, though. I think that's like I have explicitly argued against that. But it's the pragmatist theory of truth is a vacuous circle. Pragmatist theory says something is true if it works, but how do you know that it works? Well, that's a truth judgment. So there's no way you can choose truth, select something, select a model based on whether it works. We select models based on information compression. That's the underlying norm of truth that is built into our brains. It's whether or not they compress the information of experience. Because if they can compress the information of past experience, then they can predict the information of future experience if the universe is ordered and somewhat stable. So that's what's going on in our heads. That's the norm we're optimizing for. It's not pragmatism, it's information compression.
But like that view, it assumes things about the objective nature of reality, assumes that's how the brain works, in your opinion. And that's
right. It's a theory. It's a theory. Yes.
Yeah. So you're qualifying what is basically a pragmatic notion with an underlying correspondence notion of the relation of the brain to the rest of the universe and why those processes.
There's no correspondence.
Brain might work.
I don't know what you mean by correspondence.
Your description is in terms of a correspondence. You're claiming that the world is such a way, and the truth of that statement, the kind of truth it has, is it's a claim to a correspondence with the state of affairs.
I'm not sure I know what you mean because, like, there could be different models. Like, let's say the heliocentric model of the solar system. It could be adequate for our purposes, but not, or even the Ptolemaic model with the epicycles could be adequate. And so for a time being, we could commit to that model and use it. And so to us, that's true, but that doesn't mean it corresponds to real, that the motions are actually epicyclic, like that their planets are actually going backwards and forwards and going around the Earth and all that.
Right. So you're describing a problem in viewing truth only in terms of predictive validity, because we can predict accurately, and yet given more information, it may turn out that our models don't have as much predictability as some better model, like the relativity model or whatever. Again, you're relying on notions of a correspondence with a true state of affairs. You're saying there is a true state of affairs that our models are approximating. So the truth can't just subsist in the model itself.
Well, I wouldn't say there is
between the model and the actual reality. right?
I think that's a mistake, though, to think about it that way. I think there is a reality, and the reality affects us. So, like, there is a reality that corresponds to my representation of the fridge and the milk, such that if I, do this action of reaching out, grasping the fridge door, and pulling on it, the information flowing out of my brain that causes that action will regularly produce a change in my visual experience, a change in my tactile experience. So one type of experience predicts another. But it all comes out of experience. So I don't have any access to this underlying reality, nor do my representations correspond to it. They simply represent it. And they represent it in the sense that they predict my experiences. And the regularity of experience is explained by the existence of reality that is ordered and fairly
That
stable
kind
and
of
all that.
representation, though, is a relation of correspondence. If the
No.
model doesn't represent the underlying reality, then it doesn't correspond. If it
Well, I
does,
gave the
then it does correspond. It's sort of a semantic point, but if you're saying there's a relationship of representation, that is a kind of correspondence.
What I'm saying, though, is reality is of a totally different type than the representation. So they can't correspond. They're incommensurable. They can never be compared, and I can never get to the ultimate thing. So, calling it a correspondence implies that they're of the same type or that they're somehow commensurable, that we could compare one to the other. When in fact, all I can do is acquire more experience or compare one model to another, like my wife's model to my model. Or I could go to the fridge and get more experience that will then, invalidate my model of whether there's milk in the fridge. But I'm not leaping across the, mind reality gap, getting to the real thing and comparing it to a model. Nor do I have to posit that out there somewhere there is a real proposition that my belief corresponds to.
Well, given the problems that we've been looking at with regard to mathematics, I would say that you do have to posit that in order to deal with issues of mathematical truth. So I get what you're saying. First of all, it's a skepticism, basically similar to a pragmatic theory of truth. We don't really know what underlies the models, but models allow us to act. We can compare different models and kind of work on the basis of kind of what's adaptive in our environment. But
Well,
the
to be
claim,
clear,
the
it's an
claim, no,
inductive theory. It's an inductive, not pragmatic. It's an inductive theory. And it's empirical. It's based on experience. And it's also assumes that we have innate mental abilities to induce knowledge from experience, then apply it back to experience. So that's
yeah, that's
that's the
fine.
theory.
That's
And I
fine.
just don't want to confuse it
It's
with like
possible to have a
pragmatism.
model. It's possible to have a model of knowledge, though, which postulates a particular nature to that underlying existence, right? You're saying we can't know what it is, and therefore our kind of epistemic notions of truth and falsity have to be constrained within our own models. But like that's your theoretical prior, that's the nature of your theoretical construct. There can be an alternative theoretical construct which actually does hypothesize about the nature of the underlying reality, and if that gains additional explanatory power, then that would be an advantage. And I'm claiming that by postulating that there is a true nature of the kinds of things that we deal with in propositional knowledge, which are not all just concrete material claims. There are also mathematical claims. There are also counterfactual claims, and we can deal with the seeming like permanence of mathematical truth, of logical truth, of claims about universals and counterfactuals by postulating the existence of this realm of form. So that's what it's intended to explain. So if we could go back to that issue of mathematical truth, if you're saying that we invent these formalisms, they're derived from our intuitions, basically the computational capacities of the brain. We expand on those through formalized systems. When before we formalize a mathematical truth for the first time, was it already true that could you have said before anyone formulated the Pythagorean theorem that if you multiply the two sides by themselves add them together, and then
Yeah, a squared plus b squared
set
equals
that.
c
Yeah,
squared.
I know.
Sure.
Set that equal to the hypotenuse, square it. If you could conduct these, assign a value x, if you did, counterfactual statements about this mathematical operation, would those be true before we invented that formalism? You know what I'm saying?
Well,
Or
I'm
how
saying that's
was
a
it?
meaningless. I mean, I don't know what you mean by true, right? They were true within geometry. They're true statements within the system of geometry. They don't have meaning outside of the system of geometry.
So,
So
okay,
to
the
say that
issue
they're
of
like true in the universe, it just
general.
doesn't really mean anything. Like,
I used this example in a recent video. Before like a robin evolved, was it possible for the robin to evolve? And we're saying it was possible for it to evolve. We're saying it was true that it was possible for the robin to evolve, right? Otherwise, like the status of those potentials is totally indefinite. So was it possible that you could correctly calculate the length of the hypotenuse given this operation with the given length of the other two sides of a right triangle? Would that have been true before the Pythagorean theorem was discovered? And I mean, because if you're saying that it wasn't true prior to someone actually formalizing it,
no,
then
I'm
how
saying it's true
that it
within
was discovered?
geometry. So you
Yeah, but
you
then you're
use
saying geometry
terms,
is a human invention. So if it's
right?
only true, then how before geometry was invented, how could the Pythagorean theorem have had validity counterfactually, right? What if we're saying that it was possible for the Pythagorean theorem to be discovered? We're saying that true statements could have been made about the potential of the Pythagorean theorem before human mathematics was invented.
Well, what
Are
I'm
we?
saying is that we have an innate uh, ability, or whatever you want to call it, predisposition. We have innate mental processes or abilities. The brain is not random. It's a structure, and it works in a certain way, and it does certain things. Okay. And reasoning about space, spatial relationships, is built into that object, the brain. That's one of the things it does, right? It's one of the most important things it does. So we have this, innate, I don't want to call it spatial reasoning, but, we have this innate ability to represent objects in space and their relationships in space. And based on that, we develop this formal language of geometry that includes concepts like straight line, flat, hypotenuse, right angle triangle, and so on and so forth, within that system that is based on that, like, innate knowledge. So we have innate procedural knowledge of how to represent space and relationships in space. And then we constructed explicit representations, like the axioms of geometry, Euclidean geometry, based on that innate procedural knowledge, but it's not the same thing as it. You're not born with the axioms of Euclid in your brain as propositions. You're born with a brain that sees objects, and you learn from experience by moving around in the world how objects relate within space. You have the ability to represent objects in space, magnitudes, all kinds of things like that, innately, internally. And then you can construct a system that does that on sand or paper or whatever, and that's a very useful system. And it gets its, intuitive correctness from those innate mental abilities. But something like the Pythagorean theorem is true within that system. Okay, you can't formulate the Pythagorean theorem. You can't represent it until you have the concepts of straight lines, angles, triangles, and so on, which are all,
Yeah, you're
things
saying
you
it
learn in school.
develops. This particular geometrical theorem develops from our innate capacities. There's two sides of this.
I'm saying geometry. Geometry develops, not
Geometry
that.
evolves. Geometry evolves from our innate processing, from our ability to reason spatially.
Well, we
Right? That's how
constructed
it
it,
becomes
and
about.
we
Yeah,
you
we
don't
construct.
have
I
to.
know that's what you're saying. I
Okay.
know you're saying.
Well, let me just give an analogy that's really...
There are two sides of this that I've been wanting to get at from the beginning. We have to look at these issues. So on the first side, the basic reasoning abilities of our mind come from somewhere, right? And it was true that certain types of reasoning abilities could have evolved and certain types of reasoning abilities could not have evolved. If you treat the brain like a computer, then presumably it is subject to Turing universality or quantum Turing universality. And so there are basic ways in which computation, ways in which cognitive processing can take place, and there are certain ways in which it cannot take place. That's my hypothesis about the nature of cognition, that there are certain computable processes that are possible in reality, and there are certain other ones that are not possible in reality. And the difference between those possible modes of cognition and the impossible modes of cognition cannot be discerned if your concept of truth is already embedded basically in your estimation. If the propositional knowledge is only yours and the true proposition did not exist before humans, that this particular mode of reasoning was possible for a being that would evolve in this way, then you can't make any sense of the computational capacities of the universe at large. And that's what I'm interested in the truths of reason. Not the truths of any particular mathematical formalization, but what was the true possibility of reasoning systems in the universe before humans set about like what was truly possible in terms of computation and reasoning. That is like the kind of archetypal Platonic mathematics that I'm interested in, not like any
kind of question-begging fallacy. Like, we are here and we have brains that work a certain way, and then when we come up with formal systems, of course the formal systems are going to represent the way the brains work, or not represent, they're going to reflect the way the brains work, because they're derived by those brains to do the job that those brains do, but do it in a different way, like, outside the brain and on paper and in ways that the brain might not be able to do. So they extend it. But there's no reason to think that the representations that we come up with, or the formal systems, or the innate mental processes themselves exist in the same form outside of the brain. Like, we don't know what reality is, and anytime you try to think about reality, you're going to construct a representation of it, and that representation is going to it's going to be constrained by your ability to construct representations, and of course your reasoning about it is going to be constrained by your brain's innate mental abilities. So there's no getting outside of that. That doesn't mean that...
No, I mean, that's why you come up with hypotheses about the nature of that underlying reality.
Well, but there's no... My point is
permanently embedded within human modeling, then you're not going to be able to talk about anything as being true or untrue when it doesn't have to do with human affairs.
Well, that's not really a problem. I mean, we don't have to talk about...
If you're hypothesizing the existence of that underlying reality and you want to make truth claims about it to build a fuller model...
But you only make truth claims from...
that allows you to say things about problems such as what are the generalized computational capacities of the universe, not what is a particular human able to do, but what could be done by any mind, any computing system. Thinking about that question.
Well, okay, so computing systems are, again, something we invented, right? They're not that much like minds.
I'm using it synonymously with the human mind, where I'm saying we're basically a computer. And so we do carry out computations.
We're not at all doing computation. I mean, this is a side issue, but the theory of computation is based on basically you have a Turing machine, right? You have some set of symbols and you output some set of symbols. So it's about mapping from inputs to outputs, right? It doesn't take into account living in reality, like interacting with reality in real time. So the theory of computation is not
I would look at Stephen Wolfram's models of kind of computational reductionism. He actually ends up converging with a lot of my thinking, just from a very different perspective. But anyway, I mean, the
Well, I
universe
can look
has
at it, but
capacities for computation. And so if you want to deny that the human brain is a traditional Turing machine, that's fine. I don't believe it either. I think it's a combination of quantum computation and a Turing machine and something else that is non-computational. Like there is a kind of essence of the mind that can't be described as a process. But
well, I'm
anyway,
saying even the computer that you're using right now isn't, strictly speaking, it can't be described in terms of Turing computation, because that's not actually what it's actually doing. But I mean, that's a very abstract notion that was, it belongs to sort of the theory of computation and stuff. And
right. But what I'm getting at is that the limitation in the concept of truth that you're putting forward is that you can't speculate at all. You can't come up with hypotheses or postulates about questions of basic counterfactual reality, meaning
well,
like the question of what sorts of minds could potentially evolve. You can't even look at that question.
yes,
It
because I can't get outside my head and partake of some other way of thinking. I can't directly get into contact with reality. So, like, what a lot of this stuff does, this presuppositional reasoning, is we look at ourselves, and when we theorize about ourselves, we discover, oh, we can model the way we think. All right, you can treat formal logic as a model of a certain aspect of the way we think, or mathematics in that way, sort of. But we can theorize about ourselves, and then we'll discover. And you can also do this introspectively. You can say, kind of work your way back to the things you can't really deny or reject. Like, I could question whether there's a tree outside the window, but if I see it, I'm going to believe it, right? But that doesn't mean, like, when we discover the presuppositions of thought, that doesn't mean we have discovered an underlying foundation of reality. It just means that we have found our boundaries, or we have theorized about our boundaries, about our nature. So we're really theorizing about our nature. When we think about the presupposition of thought, we're theorizing about our nature, the nature of thought. This does not have to correspond in any way to the nature of reality. Now,
well, I mean, thought is real, so it must correspond somehow to reality.
What?
If thought is a part of reality, then there must be a correspondence between
right.
thought.
Well, yeah, and I was just about to say that to the extent that, yes, to the extent that our thinking seems to work, or, we theorize that when we represent reality, we are representing it in a way that is adequate for us to survive and reproduce and move around in the world without bumping into trees, right? So, yeah, I'm not saying that there's no relation. But what I'm saying is that those two things don't have to be of the same type. Okay, the reality does not have to consist of representations. Like it doesn't consist of sentences, for example, right? I can write down a description of something I'm looking at.
The question can be asked. Here, I'm going to give like my epistemological position generally, and that might clarify some of these problems. The way I look at it, there are various questions that can be asked through experience. We have a problem that we want to address with an explanation. And an answer is better than no answer if you're trying to build a complete theory, right? It's not that we have a firm foundation to know the nature of underlying reality, but if we can come up with conjectures, postulates, hypotheses about the nature of that underlying reality, then we can test out deductively the implications of those hypotheses and see if the implications of them correspond to experience, even if the basic postulate doesn't seem to correspond to experience, like atomism, right? That's a postulate about the nature of underlying reality that was put forward from a kind of deductive process originally, I would say. And from that hypothesis, then you can, if it's true that reality consists of these kinds of basic material atoms, particles, then this other list of things may turn out to be true. And then you test the implications. I disagree with atomism, but that's just an example of a kind of theory of underlying reality. And it may turn out actually to be useful to come up with a theory of underlying reality. So that's the process that I would go through.
We're always doing that. But the thing is, the theory of underlying reality is a representation. It's a model. It's in our heads, and it's constrained by our natures, and we can't get outside our natures. We can't get outside our limits. So like it might be that there's some aspects of reality that we could never represent, never understand because of our nature. It limits us. And maybe we're running into some of those. Like maybe why quantum theory is so weird is that we just can't represent what's going on down there. But that's the
question
limits
is
of our
not so,
knowledge.
right?
Hmm?
Like it's not useful to say maybe we just can't know. It's useful
Well,
to guess. It's useful to try to know,
well,
right?
it might be useful to understand the relation between yourself and knowledge, like to understand the relationship and the relationship between knowledge and reality, that we are limited, we're stuck in our brains. And also to understand that, like, not to confuse your your theory about yourself and the presuppositions of thought. Like if you theorize about, well, what I might need space and time and causality and all that stuff, right? So this is how I represent the world. But don't confuse that with some ultimate knowledge of reality or a foundation. Because you haven't discovered a foundation. You've theorized about yourself. You've theorized about your nature. And I think this is where people go wrong. They confuse theorizing about your nature with discovering an objective foundation. And those are very
that's
different.
not the perspective. I'm not a foundationalist. I would say that you have to come up with postulates about the nature of underlying reality, whatever it may be, and those can only be judged. The truth value of them can only be judged in the light of your broader theoretical framework, your broader philosophical worldview. And we can basically build on to these existing worldviews until we have a very robust set of theories. We kind of eliminate theories as they become inconsistent with data or with other, very effective theories. Like we seem to know that something is wrong with relativity and quantum theory in isolation because they don't seem to work well together. They seem incommensurate, the two of those. And so that's a piece of evidence that the general worldview containing those two particular theories needs updating in some way. But I wouldn't say that, I am supposing that we have a foundation for like absolute, no reservation, unqualified, pure knowledge. I'm saying we build up these models to explain problems, and we judge between these different worldviews on the basis of what kinds of problems we can address if we can explain data. And I'm dealing with right now in this conversation the issue of counterfactual knowledge. How can so I want to deal with the implications of counterfactuals relative to your concept of truth. In my view, if you let's say we exist not as human beings, but as like kind of just observers of a world before human beings evolved. If I turned to you as a disembodied spirit and said, it's possible that human beings could evolve here, would that have been true or false at that time?
Well, it depends on what kind of disembodied spirits we are, whether, I mean, like, I don't understand what the question is, true or false, in what sense? Like, if we, like, I just don't know how to answer the question, because it's not like you're saying, imagine that we are disembodied spirits that exist before anything happens here. So what kind of brains do we have? I mean, you can't imagine being something other than what you are, right? I can't imagine being a disembodied spirit.
Basically, what you're saying is that without a brain to observe and interpret, nothing is true or false ever.
Well, I'm saying that there's no need to posit the existence of mind-independent propositions, because propositions, or whether they're in sentences or ideas in the mind, are used to represent reality by brains or by minds.
But that doesn't mean that that's exhaustive of what propositions are. Just because humans use propositions does not mean it is a purely human thing.
Perhaps. I mean, you could posit that there's some out there, some realm of propositions, but I don't see any explanatory power that would
It's
have.
dealing with claims of truth of states of affairs that don't involve human observers. So when we're postulating, or rather when we're theorizing about the existence of the ancient Earth, before life forms evolved, we're talking about states of affairs that were true. We're saying this was the state of affairs, and all the propositions we can come up with that describe that state of affairs were either true or false. So first we can look
so
at
I can, but what I can say here is we, as human beings, as brains, are representing the past using models, constructing models in our brains, and whether or not those models predict the evidence that we have, whether they compress the information that we have, will be the basis for us judging whether they're correct or incorrect. So again, there's no need to talk about whether it's true, whether it was true to some non-existent entity 10 billion years ago. Like, what's the point of that? The only reason why you're trying to do that is because you have this fixed assumption that there must be objective truth, that these things must exist, and then you're just saying, well, if I accept your view, then they don't exist. Well, yeah, that's right, they don't. But that's all it is, right? Just you let go of that, and you're fine. there's no need to hold on to that. You can let go of it.
Well, it's not fine because everything that happened prior to the existence of human beings, then there. You're saying
there was a
no
reality there, but it doesn't mean that I have to believe the reality consisted of propositions. I think, yes, there was something there 10 billion years ago. That's my model of it.
Okay, so you're saying there were basically only facts rather than truths. There were only like states of affairs.
No, there was reality. There was reality. Like, I can't talk about it without imposing a model on it, right?
That's what I mean by facts.
Well,
so we need to look at this problem.
A fact is really just a proposition.
I don't want to skip over this. Don't move on to something else. We have to look at this. So you're saying that there was only a reality. I'm saying you could describe that as facts or states of affairs. Is that what you're saying? The past, outside of human models, was a reality, and there was no propositions involved in that. Is that right?
Well, I'm saying there's no reason to assume that there were anything like propositions, existing outside of minds in some sense in the primordial world. That there's no reason to think that my representations that I construct to explain reality are the constituents of reality.
Well, the reason I would give is that we could then account for the veracity or falsity of relations between concrete objects, which in fact existed in the past, outside of just our modeling, right? Because you're saying there was a reality, there was a something. But if you want to remain totally agnostic on it, then what you're really doing is not generating a theory about it, right?
No, I have a theory about, the world, the universe. I mean, we can construct a theory which says 10 billion years ago, there was gas and dust in this region of space and had not yet coalesced into the sun and the planets. You can tell a story about it, but you're telling it from your perspective using your brain. And the story consists of representations, right, that you're using to represent something. But the thing that you're representing doesn't have to consist of representations. Well, that's what I'm saying. And you keep wondering, and the problem you seem to have with this is that from an objective perspective, like the perspective of no mind, there would be no truths or falsities or such representations. Well, without a mind, there would be no meaning to, like if nobody spoke English, the sentence, there is milk in the fridge, doesn't mean anything. But there could still be reality.
Okay, so part of reality is not just concrete objects where they lie. It's also relations between objects. It's also possibilities that objects have. And if you don't posit the existence of mind-independent truths about those relations and modal possibilities, then like you're basically saying that there are no facts.
All I'm doing is rejecting the naive realism or the correspondence theory of truth. That's all. Doesn't mean
what
I
I'm
can't.
trying to get at is like when you postulate there is a reality there. The reality that we know includes relations, includes potentials that objects have, and we can characterize those potentials, those relations, really only in propositional terms. Like this, how does the state of affairs, how does the reality itself contain the information about its valid potentials, its invalid potentials? How does it contain information about the relations that a thing has to all other things? It's
Well,
like
I mean, all we can do.
The fallacy I'm seeing here is a kind of like assumption of local realism, right? Where
No, I'm
things
just
are
saying
just what they are
all the
where
things you described, right? You had to put them into representations. So when you talk about a relation, you're talking about it. Or when you think about it, you're thinking about it. So there's something out there that has regularity, that has order, that makes the representations functional, that allows them to compress the information of reality. But that doesn't mean, again, that what's out there is the same thing as the representations, right? Like I can have a map of the city, and that represents the city, and there's a regularity to the city that makes the map functional. But I can't walk around inside the map and buy coffee at the coffee shop inside the map. I have to do that in the city. Those are totally different things. They're not the same, right? But one represents the other. And there's no reason to, and just because when we look at the world, when we think about the world, like I use the analogy of a map because both the map and the city are out there, right? But when we are looking at the world, we're doing so through ideas, through representations. When we think about it, we're doing it through representations, and we can't escape from that. But just because we can't escape from it does not mean that reality consists of representations. All we
not a
can.
logical entailment. No, but obviously what I'm getting at is that there is explanatory power in supposing representation-like qualities, supposing that to exist in the basic reality outside of our minds.
What does that explain, though? What would it explain?
It would explain how it could be the case in that past reality that there were true possible futures from its perspective and false possible futures from its perspective.
Okay, but that's not explaining something, because that's not an experience that requires explanation. There's no evidence. There's nothing to explain there, right? You're talking about you're just insisting that it give you your presupposition, your objective truth assumption. You're not explaining something. You're not talking about something I observed or felt or whatever that requires an explanation. What you're saying is I demand that my theory give me objective truth. And that, right? I mean, that is all you're demanding. That's what you want. You're not explaining something.
No. When we're hypothesizing about the existence of a past before human beings existed, we're talking about the nature of that past. When I look at the present, the nature of the present seems to contain, not just in my mind, like modal realities. There are things that objects can do and things that they cannot do. Those capacities and potentials aren't as straightforward than the simple like material existence of the object. The things that things can potentially do, or the relations that things have to each other. I don't think I'm creating relations in my mind. I don't think I'm creating modal possibilities in my mind. And so if I'm not creating them with my mind, they do subsist somehow in reality. And the question is, how do those properties, counterfactuals and relations, subsist in reality? My theory is Platonic, and I answer the question of how those things subsist. And I'm saying they apply just as much in the past when humans didn't exist as they apply in the present. I'm aware that all of this is a model. So going back to, oh, that's just a model is pointless. We're trying to find the best model. That's the point.
Yeah, but the best model will be the one that explains the most of what we experience.
Right.
And
so let's address that question. I'm talking about counterfactuals and relations. How do those subsist in the world? Not just
counterfactuals don't require an explanation. Like saying you're demanding that the theory give you that there is truth, like that exists. There's some notion of truth that exists without a mind. So that's not something that requires an explanation. Now, if you're saying how can we, like, why does it seem that there are potentialities existing in a situation? Well, it might be that that's kind of an illusion, or that's a perspective dependent thing.
Okay,
But there's only one potential.
Let's go directly to an argument made by David Lewis, who is the biggest contemporary.
Let me just finish this.
Like, we need to, you're going over the topic instead of addressing the real issue. You're saying like it doesn't need to be explained, but it does, because like in a basketball game,
no. But hold on. Then what needs to be explained?
You can say things in a basketball game. I'm going about it. So in a basketball game, a player is about to shoot, and he misses the shot, the game ends, his team loses. If from that perspective, we can say if he had made the shot, then his team would have won the game. And like, if that is true, in fact, most people would agree you can make those sorts of claims. How is it that that statement is true? How can you make claims about counterfactuals that can be true? Or in a chess game, like if you had moved here, then you could have taken this piece. Even though it didn't happen, we can say if you had done this, this would have happened. And the truth value of that proposition we can account for with modal realism, saying there are real capacities that objects have. So that's
well, we just represent possible futures. That's what our brains do, right? They're there to make choices. So we're always making judgments. Like if I do X, then Y will happen. Okay. So we have the innate mental ability.
True or false? How can those propositions be true or false?
Well, that's not really an issue. It doesn't matter if they're true or false. In what sense? They're just, it's just a belief that you have. Well, I think if he had done that, then he would have won the game. That's my belief about what would have happened. And you could debate that or whatever. I mean, I don't see how the Platonic realm would change anything, because in the Platonic realm, you'd have the exact whatever problem, that it's a counterfactual. So it's a counterfactual.
No, because
does the Platonic realm contain the counterfactual?
I would contain that, like looking at Max Tegmark's multiverse arguments, like taking modal realism is the idea that counterfactuals exist in parallel universes, and therefore there are actual reference to these claims. So you can answer those things by saying,
well, but you can't go to the other universe, and all you're saying is that there's some imaginary correspondence to some proposition that is totally out of reach to us. But you're saying that's the meaning of this statement, that it's true, and yet there's absolutely no way to verify that, right? So
you can't verify the statement that if Kyle had made that shot, his team would have won the game.
Yeah. How do you verify that? Do you go into the Platonic realm and go switch universes and go see what happened and watch the game from a different perspective?
No, the game has rules, and deductively, given basketball has rules, certainly, yeah.
Well, it has patterns, right? I mean, it has patterns. Like, usually, something isn't scored in the last 2 seconds. So if the guy makes a shot in the last couple of seconds of the game and it misses, then it's a pretty simple inference that if he had got it in, they would have won, and if he didn't, they would have lost, right? And it's just like, I mean, I don't see the problem here. There's no problem making those kinds of judgments, but it's a judgment made from our perspective based on our knowledge, using our way of representing reality. I mean,
I'm saying, like, okay, we have to go back, I guess, to the idea of truth in the first place.
Well,
Like
you're
the idea,
but again, this goes back to my point. You're demanding that this be objectively true, and I'm saying this is a meaningless notion. So you insist on this meaningless notion, and then you say the problem with your worldview is that you don't have this meaningless notion.
the
Yeah, I
meaningless
don't.
notion, the
Objective
meaning.
truth.
Okay, I'm not. It seems like you're conflating an epistemological limitation of human beings with the domain of truth within your theory. Like, what is truth? The answer will be a hypothesis. The answer will be within your model. I understand that, right?
No, but I'm saying I don't think
what-
that there is this thing of objective truth. They're just models that represent the world in ways that compress information, predict experience, and are functional for humans. So, I mean, in ordinary language, this is why I started out talking about in ordinary language, the concept of truth is not like, it doesn't have to get to this philosophical level because we agree on how to verify. We agree on how to answer questions of truth, right? We agree that if you look in the fridge and see the milk, it's there. Okay, but we're not leaping to the Platonic realm to do that. We're just looking in the fridge, right? So that's the ordinary concept of truth is based on the theory that we have limited knowledge, limited awareness, and we can make mistakes. So it contrasts with a mistake or a lie, right? That's the point of it. But that doesn't mean that there is some objective truth or correspondence between ideas or propositions or sentences and the real world. It just means that in ordinary life, we have like agreed upon ways of making these judgments that we all kind of accept. Except when
But that description of our kind of epistemological limitations, that is all in terms of a correspondence between that account you just gave and the state of affairs.
well, no, it's just a theory that it compresses the information of experience. I don't have to use your language. I can use my language. I can say, I have a theory. It explains experience. We can, I mean, there are many layers of abstraction above embodied experience, but ultimately it's about explaining embodied experience and predicting it and generating action within it. So it's all about that. It's not about like correspondence to some ultimate reality because I don't have any way of comparing something to ultimate reality, right? I mean, if your Platonic thing was in your Platonic theory, then you could never make a truth claim. There's no verification method because you can't jump into the Platonic realm, right?
Well, no, because we are basically in that now. The idea is that we're composed of these universal forms.
But you make mistakes.
Yes, right?
Well, so then that means you're not perfectly communing with the Platonic realm. So all you can do when you make a mistake is analyze the data more carefully or go back to the fridge and take another look or whatever, right? You can't leap into the, it's like the counterfactual. You can't leap into the other universe and see what happens in the game, and you can't leap into the Platonic realm of forms and see, oh, is there really milk in the fridge according to the Platonic, is that proposition floating in the Platonic soup or whatever?
Answers like that are obviously absurd, and that it doesn't hurt.
Well, I'm pointing out that it doesn't do anything, right? It doesn't add anything because no matter what,
no, it does something in mathematics at the highest level. So if the claim is that reality is composed of these basic units of meaning, these mathematical structures, these relations and universals, rather than it's composed of only these particular things, if it's composed of relations and universals, which is mathematics basically, then when we deal with mathematical truth, we can explain why it is that we can discover mathematical structures that then have parallels in the material world. We can explain how it is that mathematical truths can be true before we actually discover them. Because the idea that
but that's where you slipped. That's where you introduced your objectivity assumption. Like I can explain everything you said up to that point. I can explain how where mathematics comes from, why mathematics works, and all that stuff. But I'm not required to. The only thing that makes objective truth or requirement is when you impose it explicitly, like you just did.
No, it's not that it's a requirement generally. It's that it is useful in explaining how mathematical truth can subsist. That was the original point. And if you're saying the problem with your account in saying that it is just a formalization, a language that we develop out of our innate capacities, then you can't deal with the potential truth of any mathematical structure that has not yet been formalized. You can't deal with what I mean, basically you would have to say, if it's not true or false before someone actualizes it, then before the Pythagorean theorem was discovered, it was neither true nor false. And that to me seems absurd.
Well,
right?
no, like I've said before, the Pythagorean theorem is true within the system of geometry.
Okay,
Just
so
like a given chess game.
Before geometry existed, was the Pythagorean theorem true or false?
Well, it's not true, or it's not time relative, right? It's system relative. So it's true or false within the system of geometry.
The system of geometry doesn't exist by
The system
itself.
of, well, but like
Your account, it only exists when interpreted by human beings.
it's a human,
right? Because the symbols don't like have reality as symbols by themselves. If you wrote down alpha, beta on a page and there was no human there to read it, those symbols are not objectively alpha and beta.
Yes, and earlier you pointed out that you can take a sentence in one language and translate to another, and then there's this meaning that we can imagine. Okay, but the meaning doesn't have any, real existence in the sense that a rock exists. It's just a construct. Like if I promise.
Well, that's your problem. You're assuming it's just a construct.
Well, okay. Sure, that's my theory. Yeah, so this is all theory, sure, but
right. We're trying to
what
see
I'm saying is
explains the nature of mathematical truth better. That was.
But you were saying that too, though. That's the point, right?
What?
Well, okay. So are you saying that in your Platonic? Well, okay. So meanings, ideas, representations, right? Yes, I'm saying they're constructs, and they're not objects.
What's that explain? How is that useful? What does that account for in reality? What does that explain?
Your Platonic realm of. Sorry, what? Sorry, say that again. What?
Well, you're saying you are postulating that propositions are purely constructed, that they have no mind-independent existence. And I'm asking, what does that explain? I'm saying giving them mind-independent existence allows us to explain how mathematical truth could subsist outside of any particular human observer.
Which is not something we need to explain.
Why? No, but
why would we need to explain it?
Why would we need to explain that? Because the implication, it's like I'm using a reductio ad absurdum. If you take your assumption and truth only subsists in human minds, or you say within a system, but the system has to be contained within a human mind to have meaning in the first place. So you're effectively saying truth can only exist in human minds.
No, look, I've distinguished. Look, we can distinguish between different instances of an idea. Like you can distinguish between different instances of a gene in DNA and the abstract gene, which consists only of information. But then you can ask the question, where does the gene exist? You could say, well, it exists in all the instances simultaneously or spread over time or whatever. But it's really just an idea that we have constructed to tie those things together, right? And so
so now basically we're just getting down to realism versus nominalism. You're saying you're a nominalist, effectively.
I don't even know what that means. I don't think I'm a nominalist. I think maybe representationalist would be better, because I believe that
nominalism, but
well, no, I don't. I think these terms refer to like some old stuff from a long time ago before people understood the brain and evolution and stuff like that. And maybe it's better to, leave those terms in the past, because I don't think they really make sense in light of our current understanding of psychology.
Okay, use whatever term you want. Let's back up though, because you said that I'm asking what it explains to suppose that propositions are purely mental constructs. You said what it explains is what now?
I'm confused. I don't know what you're asking.
I'm saying that if propositions are mind independent, then we can explain how mathematical truth can subsist as objective, as real and true outside of human cognition.
Okay, and
And
I'm
you're
saying
saying
there's no need to explain that because we are making judgments from the perspective of humans. So we're not in a position of a universe without humans or a universe without ourselves. We are making the judgments. We are using these things to think. So
let me put
this
it
is
like more straightforwardly. How is it that a mathematical discovery is made? Because there are some mathematical claims that turn out to be false. They're proved
sure,
false.
right,
There are other
exactly.
mathematical truths that turn out to be true. Now,
Right. So
were they
it's,
true or false, a potential mathematical claim, is it
and I've
true or
already answered
false?
this several times. It's within the system of mathematics. You can't say true or false without qualifying it. If we're in philosophy, if we're not in the ordinary language, but if we're in philosophy, then we can't use these terms loosely. I'm saying there's no meaning to those terms unless we're qualifying them. Like there's no meaning to say this mathematical statement is true unless we understand that means it's true within mathematics. So it means it
So,
follows from the axioms and the rules of inference of mathematics. And the truth is the theorems are discovered inductively. Somebody guesses maybe this is the theorem, then they try to prove it, and then they think they have a proof, which is a valid chain of inferences from the axioms, but maybe they make a mistake.
right.
Somebody checks it and says, oh, you're wrong. Right. So the theorem is inductively, to any individual, it's inductive, it's uncertain, it's empirical. To the system, it is deductive because we define the truths of mathematics as those statements within mathematics that are derivable by the rules of inference from the axioms of mathematics. And that's it.
Yeah, and they can be spun out indefinitely, right? There's an infinite number of potential mathematical truths, right?
Right, right.
Right.
Because we
So,
designed the system in such a way that it generates an infinite number of possible theorems.
okay, so now I guess, again, we're getting back to why does mathematics work at all? It's not just an arbitrary set of axioms. It corresponds to computable processes. It corresponds to the kinds of mathematical calculations that can be done in this reality. Surely there are other kinds of mathematical calculations that cannot be done in
Well, I
this
don't
reality.
know. I mean, I don't know that there might be other. I mean, when you say mathematics corresponds to the kinds of mathematical calculations that can be done, that's just a tautology, right? Because you said mathematical. Now, if you're saying mathematics covers every possible kind of information processing, uh, I don't know. How would I know? Like,
Okay, what I'm getting at is let's just look at within the formal system, and it's not just one formal system. Obviously, there are many formal systems, many different sets of axioms that are used in math. But within the collection of human mathematical languages, there are infinitely many deductive conclusions that could be arrived at. You're claiming it's inductive. I think you're not right on that, but let's not
I'm
debate that.
clarifying the nature of it, that we arrive at these things inductively. You know that because you know you can make a mistake. So, it's not like we just commune with the, magic realm of mathematical truths and just the theorems just are there or something. We have to constructively persuade ourselves
I think
that
but
something's a theorem.
induction is not just through experience, right? Induction is looking at many cases and then generalizing a theory from many particulars. And that's not what we're doing. We are doing
Well,
deductive,
then we could call it
synthetic
something if you want
stuff.
to be. I mean, yes, we're not inducing it in that way necessarily, although that can be part of the process of arriving at a theorem. But what I mean, so maybe you don't want to use the term inductive, but it's empirical because you have to you have to find the proof and verify the proof, right? So it's kind of like you're exploring a city and you're making a map as you explore the city, right? And you could, become confused and make a mistake drawing the map or something like that. But you're exploring the space that is defined by the axioms of mathematics and the rules of inference. And
But I didn't want to have to go to this yet, but like, what about Gödel incompleteness? The whole idea is that there are mathematical truths that are not contained in a formal set of axioms that cannot be calculated in a formal set of complete axioms.
Basically, Gödel's incompleteness theorem is really just that you can construct self-referential paradoxes within mathematics. So some statements are their truth value is not determined. They're
not paradox. You're not dealing with paradox necessarily in Gödel incompleteness. That self-reference.
Well, he's basically just constructing this sentence is false in mathematics. That's all it really is.
No, but the point is not to like generate paradoxes. The point is to generate claims, that is propositions, to generate mathematical propositions that cannot be proven using the axioms of the system. And yet we can know through an informal kind of reasoning that they are true.
Well, I'm not so sure about that. Give me an example of something we know is true informally, but can't prove.
I would have to, reiterate what Gödel did with Gödel numbering, and I don't obviously remember.
Well, again, the Gödel, the whole. Well, okay. As far as I understand it, it's just. It is just as I described it. It's that some statements, because of self-reference, can be undecidable, so that the statements that you can construct in mathematics, if you allow yourself self-reference, are not dividable into truth, into the true statements of mathematics and the false ones. There's this other.
And I'm saying that is not the result, and I'm not going to be able to prove this because I can't remember all the details of what Gödel did. But the point was that there are results that are not calculable true or false. They're not provably true or false using like a set of axioms and a set of logical operations. But the conclusion is not that those things cannot be decided. The point is that we can actually know them to be true or false.
Well, I don't think that's the case. That's where I
read Gödel's paper. Go through whatever summaries you need to. That is the implication.
But we have our version of this in computing science, right? It's the diagonalization proofs and uncomputability theory and all that stuff. And I think it's all the same, but yeah, I have, like books on that sort of thing on my shelf if I really wanted to go read up on it. I think people make a lot of it just because it's one of these things that seems kind of mysterious, and so people they use it to sort of they use it as a mysticism is appealing to ignorance to support a positive claim, and I think people use Gödel's incompleteness theorem in that way. And I don't really think it says very much, actually. I don't think it's all that interesting.
Well, people should look into it for themselves. My claim is that what Gödel incompleteness proves is that there are true propositions that we can know to be true that are not calculable.
But how do we know that they're true, and in what sense are they true?
It's like a kind of informal reasoning that you do, and mathematical reasoning is never like purely within the axioms of the system. There are always kind of prior reasoning processes that go into constructing the system in the first place, and they're.
Well, if that were the case, then what you would do is you would widen the definition of mathematics to include whatever these informal reasoning things are, and then it would become decidable. But that's not, I don't think that's the point. The point is that there are undecidable statements within the language of mathematics.
Using the proof, the methods of proof acceptable within that axiomatic framework, but not that they're undecidable, period. The point is no one complete formal system can be fully decidable. Well, using its own axioms.
Look, you can just say
let's
the
go back to
sentence is false, right? I mean, that's a very simple example. You don't have to get into mathematics. It's an undecidable statement because it's not true or false. It's circular and has a negation in it and just loops forever, right? So it's like to determine the truth value of the sentence, you have to know the truth value of the sentence. And since you can never know that, you can never answer the question, is it true or false? So it's very easy to construct undecidable statements in English, right? But that I don't see what this has to do with what we're talking about.
Yeah,
I mean,
well, going back to, let's just look at the issue of mathematics again. So by postulating a real existence for propositions and also relations and universals in other contexts, we can make claims about how a mathematician discovers a mathematical truth, because the truth value was already there before they actually formulated the system. So when you lay down a set of axioms, it would seem that in your view, simultaneously, there are generated an infinite set of true propositions that can be decided within those axioms.
Yeah, you've defined a representational space, and within that space are an infinite set of, yeah, like again, chess isn't infinite, but define the rules of chess. Now you've defined a space that has a certain set of possible games in it.
Right. And so is it true then, the moment you first lay down the axioms, you haven't tried to test out their implications, are every single one of those mathematical propositions that can be said about that system true or false before we actually
True or false with respect to what?
With respect to the axioms of the system.
Well, they're true or false with respect to the axioms of the system. Once, when you define the system, you define whether they're true or false with respect to it. So, I mean,
Right.
it's not something that exists in the world. Like maybe you're confusing the idea, like, the system as an abstract concept. It's like the gene as an abstract concept. It's just we can think about the system in and of itself, right, as a set of ideas separate from any brain having the system in it, right? But the system does not exist. So the system does not exist as like an object. It's just something that we can, think about. It's just a possible thing we could imagine, like the game of chess, right? It's something.
I'm not
Did the game of
understanding
chess
the ontology then of these true or false propositions. So I'm saying you lay down a set of axioms. There's an infinite set of propositions that can truly or falsely characterize those axioms. You're agreeing that there is that infinite set of propositions, but how because you're saying that there is that infinite set of propositions that would agree with the
defined by the system, and the truth or falsity of them is also defined by the system, just like whether something's a checkmate or not is defined by the rules of chess, right? So now let's say we went through a time machine and we went back before chess was invented, but we knew what chess was. We'd had the idea in our heads. We could then play a game of chess, right? Like, of course, this involves time travel, but right? Or two people could independently come up with the same game of chess or tic-tac-toe, maybe. Okay. And it would be the same because it's the same, has the same rules, but they came up with it independently. I mean, that's possible, but none of this is really. I mean,
yeah, what I'm getting at is how does this it seems like you're saying two contradictory things. You're saying that the set of true propositions that describe the system are like self-referential within that axiomatic structure. They are true. They have truth values, real truth values.
within that system. Within that system,
right? But then, like, where does that system exist?
Nowhere. It's just a construct.
Okay, then they don't exist. Then,
well, let me ask a question.
Doesn't exist, then neither do the truth values.
Where do laws exist?
Which laws? Like human laws?
Yeah, human laws.
Well,
where does the law against drunk driving exist?
Yeah, I mean, it seems distributed, right? Which is why the theory of forms is helpful.
I wouldn't say it's distributed. It's just it's a construct. We came up with it, so somebody wrote it down. But then let's say the piece of paper they wrote it down on burns up, that doesn't mean the law ceases to exist. It's just a construct. We constructed it. Like if I promise to help somebody move tomorrow and we both forget about it, the promise still exists in some sense that I made it when I uttered the words, I will help you move tomorrow.
No, but we're totally ignoring with these examples the core problem that I'm pointing to with this issue of mathematical systems. So you're saying they don't exist anywhere, and yet how is there an infinite set of true propositions? How do those truth values subsist if the system doesn't exist anymore?
Well, they don't exist as objects, right? They're part of the system. So if you get the system into your head, if you learn the system, then you can derive the true and false whatever propositions from it if you want to. Just like if you learn the game of soccer, you can go play soccer, or if you learn the game of chess, you can play chess. So
yeah, but you're saying like the system can have a mind independent existence, right?
Well, not physically. I mean, it's not a mind independent existence. What do you mean by mind independent existence? It's like
I guess not dependent on any one mind. Like the system of mathematical axioms we're talking about could exist in any number of minds, right?
Sure, it's like the sentence, there is milk in the fridge. Could be said by many people, right? The English language exists in many minds. Where does it actually exist? Where does the actual English language exist? Well, it's kind of a fiction that we made up, right? But it's not really a fiction. It exists in this, again, yeah, sure, you could say it exists in a distributed sense, but that's not really what the English language is, right? It's just, we imagine that it exists in a way to think about it. Because we don't want to think about every single person having a certain structure in the brain, and everybody's version of the English language is slightly different.
Yeah. Applying that
abstract from all of those things.
Mathematical example, applying that analogy to that example of math, it's what you're arguing is the basic. I'm just going to say the word nominalist point, which is that like we each have a particular state of mind with English language. There is no one universal English language that we're all participating of. It's only ever particulars here and there, right? With mathematical.
I'm not saying that.
What are you saying?
Well, I mean, you learned the English language, right? You didn't learn it from one person. You learned it from. I'm saying it I mean, I'm saying we can think of the English language as existing, but that's sort of a fiction. Just like you can think of a cloud sitting on a mountaintop as an object, when in fact it's just when water vapor enters that region of the air, it condenses, and when it leaves, it evaporates.
That is what I'm saying. You're saying that is nominalism. So there's no true English language. It's a fiction, meaning it's just a name we give. It's a heuristic, basically. It's a heuristic device, right?
Well, I think there is. I don't know, because I don't know what nominalism is. I'm not going to commit to some term that I don't.
It's just
really
contrasted to Platonic realism.
Yeah, but I don't. I think these old dichotomies are bogus. Just like synthetic a priori or whatever. Kant's notions are bogus. I don't buy into that stuff.
You can't really know that unless you read the stuff, and a lot of those guys were smarter than we are today on average.
Well, I don't know about that, but we have a lot of access to knowledge.
IQ.
Kant knew nothing about biology or the brain.
Yeah, that doesn't mean that there aren't real insight. I'm just saying, like
I'm not saying there aren't real insights. I'm saying that let's go back
to forget the name nominalism, but that is the basic argument is the structure of nominalism, that there is no true English language. There's just it's a useful fiction. You called it a fiction. It's a name that we give to this thing that doesn't really have a universal existence, only ever particular. Applying that to the mathematics example, this system of axioms. Okay, where does that system exist? Is it like the English language?
Well, it doesn't exist. It doesn't have that kind of existence. I mean, it's like asking, where does the gene for, I don't know, like where does the gene for? I'm trying to think of something that's for some enzyme that's in the citric acid cycle. Just make up a name. Where does gene 46A exist?
Yeah, and I mean, you can't answer it. The Platonic realm is where it exists. Just
Well,
like all
I don't
forms.
think we need to answer the question. I think it's just it's an idea that I can use to
It's a
say
heuristic. It's
all
a
of
name.
these.
It's a label.
Well, I don't know about the word heuristic. It's a I can have the idea of the gene consisting of the nucleotide sequence, and I can say that this nucleotide sequence occurs in these billion organisms, right? But the sequence itself does not exist in space and time. It is not an object. That's what I'm saying.
Right. And so there is no such thing as the gene, properly speaking. It's
Well,
just kind of a
there is, but
fiction.
it's not an
Useful fiction.
object. It's
Then what
not an
is it?
object.
What is it?
It's the gene. I mean, it's a sequence of nucleotides. It's a particular configuration of nucleotides.
Right, but those a particular configuration of nucleotides exists in many different places, right?
Sure,
Not just
it is realized in, let's say a billion organisms, but the sequence, I mean, so you could say the sequence exists in all of those organisms, but the sequence as an abstract idea or concept is something that we use to identify a relationship between those billion organisms, right? So we abstract this notion. And once we have abstracted it, we're not talking about an object. We're talking
yeah, I
about a
get
form, right? Now, this
this is,
form
but
does not
just
have
to
to exist in some
clarify,
Platonic realm for us to
you're just
abstract it.
saying that. You're just saying that. So
Well,
the
yes, I'm
problem is
saying that. That's right. I'm saying that. There's absolutely
don't
no
say it
reason
has
to
an
believe.
existence in
Well,
some
I'm just,
Platonic.
hold on.
If
I'm
you
saying,
say,
yes, just wait. I'm saying, yes, there's no reason to posit that it has some other existence in some Platonic realm that you cannot see, you cannot observe, you cannot show me, and that has no explanatory power. So, yes, I'm saying I don't believe there's some Platonic realm out there in which this thing exists as an object or something. I mean, in what sense would it exist in the Platonic realm? Is it an
as
object in that realm? Is it a physical
as a set
object?
of relations, as a set of relations, as a
So as a
mathematical structure,
form. So as
as
a
a form,
form.
right?
Okay, so what is and now you have to answer the question. What's the nature of its existence in this Platonic realm of forms?
What is the nature of its existence?
Yeah.
What do you mean? What do you mean nature of it? It's a set of relations.
So it doesn't have so it's not an object then, right? It doesn't exist at a point in time or space or whatever. So
Yeah,
it's just
no
a
point in
form.
time or space. It's a timeless
Okay. What does this then?
informational
What is
identity.
this realm?
It is the ground of space and time. In the
How do you
same
know
way
that?
that, like,
How do you know that? What does that mean?
from the
What does that
context of
mean?
my holistic theory, from the context of
Well,
my
so in
holistic,
your theory, there has to be some
I
other
would go through
thing. I'm
specific
saying,
points
okay,
to
so I'm saying,
justify that. Most physicists today believe that space and time are emergent out of information, that space time is not fundamental, right?
well,
So
whatever.
information is not within space and time. Information generates space and time. That is Platonic realism right there. The information already exists outside of space and time.
Yeah,
And
whatever. I mean, look,
I'm
this
saying
all
that's
gets into circular
prevalent
reasoning. I mean,
position among modern physicists.
there's no information without, like, to a subject without experiencing it or thinking about it. But
Well, information is conceived today to be a physical quantity. It actually has,
yeah, and
like,
that's just silly. I mean, that's absurd. But
there's a 2018 paper where they describe, like, how they can quantify the mass of information experimentally. You can look into that. But
yeah, I could.
I
But
want to get to the philosophical stuff because there are many
no, but
reasons
look,
why I
let me
posit
just.
the Platonic realm.
Okay,
It's
look.
useful in a bunch of different
Here's
ways. But I
here's
want to get, you need to stop moving to a bunch of different topics and let us
no. I'm
actually
just
look at
giving my
the example we look
perspective.
at.
Look,
The
I don't
example
have to.
of
I'm
the Platonic.
explaining why I don't
No,
have
no,
to
no.
accept.
I don't want to move on to a bunch of different topics
What? How am I
before we
moving
actually
on?
examine all the implications of a
You
given
just I'm
case.
explaining what how am I moving on from something? We're talking about the
I want to go
Platonic
back
realm,
to
the
the
gene.
mathematical system because the core problem with it, why Platonic realism is useful as opposed to nominalism, we haven't addressed. We haven't gotten to the core of it. We have to go
I
back
think we've
there.
been talking about it the whole time. But I'm
and the
saying
point
your
was
notion of the
lost.
Platonic realm of forms is, you could just call it the space of possible representations that a human mind is capable of.
But what about the question? I agree with that formalization up until the human mind. It's the set of possible representations that mind could come up with. Because what that is exhaustive of the realm of forms. What are possible representations entertainable by mind in general, not just human minds?
But we'll only
But
ever get the ones that we're capable of, right? So from our perspective, whatever the Platonic realm of forms, if whether it exists, doesn't exist, whatever, it doesn't really matter, right? You're talking about genes, whether it's genes, chess games, milk in the fridge, whatever. We're talking about mental representations in our minds. And you're saying, where does this abstract notion of the gene exist? Well, it exists as a possible idea in a human mind. Okay, so I think that's that's the counterpart to your Platonic realm of forms. You're
but once
taking
again, like you're saying, it exists as a
no,
possible idea in a human mind. That's what you just said. It exists as a possible idea in a human mind. How does it exist as a possible idea?
because a human mind can think it. A human mind can abstract the sequence of
Right. And
nucleotides from.
surely there's an infinite set of possible ideas and an infinite set of impossible ideas, things that we can't, a round square. We can't think that, but there are many
Sure.
things that we can think. How does the set of possible ideas that human beings can think of subsist? It doesn't exist in any one mind, it doesn't exist in any one place. How does that set of things, you're saying that true statements can be
Because
made about it.
the human
How does it
brain
exist?
is similar, right? We have the same kind of brain, so we have the same capacity for representing these things. Well, not everybody might have it. Some people might not have the ability to represent certain forms, but
You're missing the question. The question is the nature of those capacities. You're saying we do have certain finite capacities. There is a particular set of ideas that the human mind can contemplate. You're saying that, right? So
right. Yeah.
how does, and it seems that I would contend that in saying that, you are saying that each of those individual forms is truly possible, and the infinite set of forms that human minds can think of hasn't actually been thought of. It's all potential, and yet
Right.
it seems like you're saying each one of those possible ideas is either a true possible idea or a false possible idea.
No.
And
What's that
so
got to
then
do with anything?
okay, you could get around this by a deflationary theory of truth that says that to say X is
I've already
true is
given you
just to say
I've already
X.
no,
But
I've already said I reject objective truth, so there's no way I can say these are true or not
okay, well,
objectively. They're
if
just
you're, let's look at that implication then. If you're saying that that infinite set of ideas that a human mind could contemplate is not true or false, then you're not saying that there's a definite set. You're saying that there's no difference between possible and impossible ideas that the human mind can contemplate if they're not truly possible or impossible before we look at them.
no. There's a difference between the forms that you can contemplate and whether you judge them to be true or false. Like
No, that's not the question.
I
That's
can
not the question. The
imagine
question
milk
is,
being in the fridge or not in the fridge right now.
please
But I
don't move
only
on to another example. Let's stick with this example because we keep on dancing away from the issue. The point of the example is to say, if you're saying there is a set of possible forms, you're saying there's a true set of possible forms.
No. What's true? What does true mean in that statement?
True meaning the claim that human beings can think of this set of things would be true. And the claim that the human being could think of an alternative set of impossible forms, incoherent
No,
forms,
I'm just
would be.
saying that there's a space of representations a human mind can construct. Now
Right.
you're
And so
going,
where
now
does
you're
that
backing
space
up
of
and
representation, you're talking about a probability space, right?
I'm just talking about a space of representations. Like a language is a space of
Of
sentences, right?
possible representations, not actual representations, right?
Yeah, like a
Many more of
language
them
is
are
a set of
just
possible
possible.
sentences, right?
Right. And how does that system, and this is what we got to before, how does that language system exist? And you said like it doesn't exist in any one place.
That's the point of saying it's the space of possible representations that a human mind can construct. That's the sense in which it exists. That's the point.
But when you say it is that space of possible x's, you're saying it is that space. For me, I know where that space is. I have like I identify it as
yeah, and I think you're imagining that as a physical thing, as an object or something. And you're also imagining, that in this object, the Platonic realm, that all these representations not only exist, but there in that magical realm, they have they're divided into true and false categories, right? I
mean, that's not quite it. I mean, we haven't really gotten close to the theory of forms I would subscribe to. Ultimately, within the realm of forms, truth is relative to the level of being you're operating on. It's everything is forms, everything is mathematical relations, ultimately. But anyway, like I said, I don't want to dance away from this issue. If you're saying you set up a system of axioms, let's go back to that. You're saying there is a probability space or a space of possible mathematical representations, and yet you're saying the system doesn't exist anywhere. So it seems like you're saying this set of possibilities exists.
Well, I'm saying it's not physical.
It also doesn't exist.
Is mathematics a physical object?
No.
Okay, so then why would the space of all possible representations of the human brain can construct be a physical object?
I'm not saying that it would have to be a physical object.
Okay,
but what kind
so
of
it's not.
existence?
So good. So it doesn't exist anywhere then, right? There's no where because it's not physical. Physical objects exist.
If that thing has no existence, if the system, an abstract mathematical system has no existence, then you can't at the same time maintain.
Well, I said it's not physical. I said it's not physical. I said the sense in which it exists is precisely that it's the space of all possible representations that can be created by a human brain.
Space subsist?
I just
said,
what
is that space?
It's the space of all possible representations that a human brain can construct.
Okay, and so you're saying like probability spaces generally is the concept we're talking about. You're saying probability spaces can, in some sense.
I didn't say anything about probabilities. I said representations, ideas.
I know. I'm saying the general class of that space of possible representations. The general class is probability spaces. That's the most general way to put it.
I don't know what you're saying. I have no idea what you're saying now. I don't know how that relates to probability.
Okay, you're saying the space of representations that a human being can entertain. That is a specific example that would fall within a broader class of entities that we could call probability spaces. So rather than just the set of X's,
I don't see any relationship there. I mean, and the English language is the English language a probability space?
You could.
It just defines a set of sentences.
Okay, let's. With what it seems, the contradiction seems to be, you're saying there is, in some sense, a space of possible mathematical representations within a given axiomatic system, but then in the same breath, you're saying that the actual system only ever exists in a particular person's mind or multiple people's minds. It has no other location, right?
Again, I don't know what you're saying. I said already, I mean, if we're talking about the space of all possible ideas, we're talking about all the possible ideas a human mind can represent. We're talking mathematics. We're talking about all the possible
sentences. We're going more specific than that. We're going more specific than that. We're constructing a specific set of axioms. We're defining a kind of local mathematical language. Right now, we invent this system according to your language. We create a set of axioms. At the same time, are there an infinite set of true deductions or inductions or true entailments of those axioms? Is there an infinite set of true entailments to those axioms?
Well, if we design the system so that it has a definition of truth which is, if it follows from the rules of inference of the system, then it's true, right? Like formal logic or something. Then we're defining a space of like, let's say propositional calculus. I mean, I really don't know where you're going with this because I don't see the point, but whatever it is, a formal language defines a space of possible statements in the language, propositions, whatever. And if it's something like the propositional calculus, then it also defines methods for deriving the theorems of the system.
Uh-huh.
Okay, and the theorems are true with respect to the system, period, end of story.
Right, but where does that system exist?
Well, we've already gone through this. It's not physical.
You can say what it's not, but what is it?
Well, it's not physical. So, I mean, what more do you want to know about it? It's a system that we invented, like a language.
Okay, but the system is never complete in any one person's mind. If it has an infinite set of true entailments, which it seems like you're admitting.
Well, if it's never if it's never complete, what do you mean by complete? You mean all the entailments are not in any one person's mind?
Exactly.
But the ability to derive them, the mechanical, the process, whatever, the rules could be in many people's minds, right? Like
Sure.
Okay.
Yeah. But then what accounts for because the explanatory advantage in supposing the real existence of that set of true entailments is that then when we discover a mathematical truth, it's not like it wasn't true or false before we found it, right? It really was something, and then we discovered what it is, even if that's a localized
but we're not disagreeing on this. We're not disagreeing on this.
I know.
It's true or false within mathematics.
I know that's what you've said, and that seems inconsistent with the other things you've said about mathematical systems.
Like what?
Because where exactly is the truth value of one of those infinite propositions?
What do you mean by where?
derivable?
Are you asking for a physical location?
No, I mean, I wouldn't put it in a physical space. I would put it in a pre-physical space.
Well, then what are you asking? Are you asking what makes it true?
The idea of not like where in space is it, but in what does it subsist? Any structure,
in the axioms of the system. In the system.
Okay, but you're saying the system doesn't have like some Platonic existence. It only exists for particular minds, is what you're saying.
Well, I'm again, when you say exists, it's like, again, we go back to the gene, right? It's just, it exists in the space of representations, which is an imaginary, it's a metaphor. It's not really a physical space, right? So we can invent a system that has rules, and then that system can be learned by many people, and they can use it to derive the same theorems or to test each other's theorems. So it's like the abstract gene, the abstract system. If we seem to see copies of it here, there, and all over the place, right? So there's an abstraction that we are capable of understanding and teaching others, so that can propagate from mind to mind. Now you're asking me, where does it exist? It's not a physical thing. It's like asking, where does the abstract gene exist? Where does that sequence of nucleotides really exist? Well, that's a meaningless question. It's just a sequence. So again, I mean, we're just going back to the circle. You want it to exist.
In terms of the explanatory power of this, if I say the system does have a Platonic existence, meaning it's not dependent on human minds, it's not invented truly by human minds. Human minds constructed symbols that allowed our minds to resonate with this eternal structure, which was, possible and true from the beginning of time. That, if that is true, then there's a way and a place in which each one of the true propositions which correctly characterize entailments of those axioms subsist. And that's exactly the central point that I was getting at. That's the argument for God as a ground of truth that Jay makes, that other theists have been making. That's the basic question at issue. And if you don't posit the Platonic existence of that system, then the idea that there is an infinite set of true propositions which characterize entailments of that system is meaningless, because
You
there's
can't
no.
even say what this Platonic existence is. It's just a metaphor. Like, in what way do they exist?
Well, in the sense that like so in Platonism, right, the most basic thing that's presupposed by any other thing is just unity, right? Unity is the most primitive thing there can be. And then beyond unity, you can have the idea of a limit, and then you can have the idea of the unlimited
But in
thing.
what
And
sense
there's
does
many ways. Now, I'm saying like this is a fundamental ontology. It's a basic metaphysical theory about the nature of not the physical world exclusively, but reality itself.
the
And the
game of
claim is,
chess existed 10 billion years ago, or 10 trillion years ago, according to you? Is that right?
yes,
Okay. In what sense did it exist?
the idea is that the most, so first of all, this is like a temporal B theorist view, not a temporal A theory. Time is not fundamental. Space-time is not fundamental. Structures, eidetic structures, formal structures, information, relations between things that are not like material objects, but relations between abstract objects are fundamental. And you can have there's a hierarchy of these things going from the simplest relations, which have the most
But wait,
instantiations.
you're not answering the question. In what sense do they exist? What do you mean by fundamental? I mean,
This is like Max Tegmark has the easiest to defend position in current scientific language, which is the mathematical universe hypothesis. That's rather than positing like some basic units of matter underlying what physics describes, physical systems, he takes the move of saying that physical systems simply are the relations that we track with mathematics. This is like ontological relativism. What things are fundamentally are sets of relations. And there
what's a
are
relation?
relations. A relation, I mean, it's tautologically defined. In mathematics, it's always tautologically defined. It's a relationship as defined according to the symbols that are brought into being.
So again, it just comes back
generate.
to it's a possible mental form that we can comprehend, right? That we can imagine or that we can have in our heads. And you don't know, like you don't know that there might be forms that you can't get in your head. You would have no way of knowing that.
That's really not the point of this. That you're asking like, where is the Platonic realm?
You know, I mean, you're saying there's some big deficiency in not positing this realm, but this realm has no real existence. It has no it has no empirical.
No. Here's Tegmark's argument for mathematical reductionism. So if the only thing that exists at a physical level, the most accurate description we have of physical reality is the relation between basic quantities, right? We can't get any more specific in our description of physical reality than mathematical relations, like many dimensional relations between quantities. There's nothing more fundamental than that. And so these quantities are basic. The relations between quantities are basic. And space-time is emergent out of basic relations between quantities. That's also, again, Stephen Wolfram. His model.
I think this is just projecting. This is just projecting
sets of basic relations. No, look at Wolfram's model, because he has like I don't know.
There's nothing that this explains. I mean, there's just nothing this explains. You can just understand. If you want to think of it as a Platonic realm metaphorically, that's fine. But all it is the space of possible ideas that you're capable of contemplating. And that space is metaphorical. It's just, when I say the space, I'm not saying a physical space. It's just you have a brain that works in certain ways, so it can construct certain representations, right? So the space of all possible representations.
I mean, we can look at Chris Langan's argument of syndethenesis, that basically you're saying the mind, the representations that we can generate are linguistic in nature in some sense. Meaning,
I don't think they're linguistic. Objects. No, I'm not saying that. I'm just saying they're representations.
Us, right?
Hmm?
Sorry, they carry meaning to us. I would say that they're a model. You would say representations are a model, and that model is about, presumably, something. that we're trying to adapt to in whatever
Yeah,
sense.
there's a reality, and we
That's the sense in
represent.
which it's a language. It represents.
Well, I
Models,
mean,
representation represents, just like language represents.
yeah, I mean,
So
look, there's.
let me
Hold
get the
on.
point out. Let me get the point out.
Okay.
Syndiphonesis is the idea that a given language has linguistic objects and a common syntactic medium that binds them. There's a common set of laws, a common syntax that renders those two objects, those relands in his terminology, or relata, intelligible as relata. And so we have a relation as minds between ourselves and reality. At the very least, we are a part of reality. We are related. We have, therefore, as two related things, the same underlying syntactic medium. Otherwise, you can't really
No.
put forward the existence of those two things. No, saying in language, there is mind and there is reality. Those are two linguistic objects. The mutual relation between them is unintelligible unless we are positing that they have a common syntax which joins them. There are common laws which bind them together.
Well, there are common. They're both, yes, real. The brain, the mind is, whatever you want to call it. It depends on the brain. So yes, there is physics that binds together these things, but that doesn't mean that the way the brain represents reality is the same as reality. I mean, it's not the same thing, right?
Of course.
I mean, paper. No. I mean, like,
but it would imply that the building blocks of representation come from that underlying reality.
Sure. Nobody's denying that.
I mean, basic forms, the most basic categories of reasoning, the most basic logical operations, we can suppose to have a ground in those laws of physics and the basic underlying reality, right?
Well, all we can suppose is that these brains are functional within the world that they exist and at the scale at which they operate. I mean, that's all we can presume. Like, there is order to the universe. So we can say, yes, the universe must be ordered, or there's no way I could make sense of it. But that doesn't mean that my sense making of it is capturing the underlying reality of it.
I mean, your mind being a part of reality must at all scales be operating according to laws of nature. The idea, though, is that some of these laws can be totally like human inventions, like the game of chess, meaning.
Well, let me just use an analogy to sort of clear up a potential confusion. A computer works according to the laws of physics, right?
Mm-hmm.
Does that mean that a computer knows the laws of physics? I mean, does that mean that the computer has in it the laws of physics because it's made out of silicon and it works according to the laws of physics?
No, but the interesting question is, does it mean that a computer, given enough, I mean, if you believe that computers could have intelligence, like true intelligence, given enough intelligence, it could derive the laws of physics because it is subject to them?
Well, it may be able to derive them because from data about the world, if it can conduct experiments and all that stuff, it may be able to derive a representation of its underlying reality. But it's deriving a representation of its underlying reality. The point is, just because it is a physical object does not mean that it has explicit knowledge of the laws of physics. Right? And like a rabbit does not have explicit knowledge of the laws of physics. Its brain is made out of matter. It's
it energy. I wouldn't say that it would, but the idea is that every mental operation is according with physical law. Of course, every mental operation is in accordance with law, but it's not necessarily a ubiquitous phenomena. Like mental laws or habits that we are talking about at a high level are not necessarily universal. Like a rabbit might care about reproducing, but that drive to reproduce is not universal for all beings, right? There are some beings that are real that don't have a drive to reproduce, but they're going down further. Nothing
has a drive to reproduce, but that's a separate thing.
Semantic. So there are different levels of how fundamental the laws that an organism or a computer are living by get. And the most basic laws are going to be those basic categories, logical operations. I mean, fundamentally, like the set, the idea of a basic set, a unity, accountability, like these sorts of Aristotelian categories. Like there are different ways of, or the Kantian categories of understanding. Like these most basic kinds of relations are going to be closer to the fundamental laws of physics than like high level, very particular processes, like, you know, what you do when you're blacksmithing or what you do when you're playing a piano. Like these things are not universal, but they're very basic mental things that get closer, that therefore are more universal as phenomena.
Well, they're right? Getting closer. They're universal to the brains that have them, and they're getting closer to the basic operations of the brains. But that doesn't mean that reality consists of logical calculations or propositions. So that's where you're making a leap.
Well, yeah, and I wouldn't say that I logically derive that conclusion. I'm not saying that it's a logical entailment.
And a brain, I mean, this is...
I'm looking at this as like reasoning about why we might suppose that the forms of mental representations that we have are actually reflective of the underlying reality. Is this relation of law, the particular law of a human mind versus the fundamental law? And there seems to be a continuum between less universal and more universal laws. Like there are things that we identify that any thinking being would identify necessarily, like the subject-object relationship, something that basic. You can't really omit that and still have cognitive processing. That, I mean, those
probably
sorts of things,
not.
Therefore, will be more universal.
Well, probably not, but we don't know. But here, look, there's an important... I mean, I can give you a reason why they're not going to be the same. Because there's a huge difference between a brain and objective reality, right? Like a brain has to represent reality using the information that it gathers from its own body surface, from its eyes, ears, and it has to act in the world locally. Like a brain might have to, you know, calculate the trajectory of something falling to avoid getting hit by it or whatever. The universe doesn't have to calculate from a position of limited knowledge. It just happens, right? Like the calculation might just be built into every particle of the universe or whatever.
Okay, if that's the case, if it's holographic, then...
Well, I'm not saying it's holographic. I'm just saying that there's a big difference between a brain, which is very limited, and the universe, right? Like it's very hard to calculate. Like, for example, the three body problem. We have these laws of motion, but we can't actually use them to calculate the motion of more than two bodies in space. Like precisely. Because we are limited. That doesn't mean nature can't generate the motions, right? Nature's generating the motions all the time. We've extracted this knowledge. Okay, there are these laws, but to actually...
This contention is not addressing the point that I was making. So finite beings are limited in that the extension of application of the basic order of reality is finite, whereas reality itself is fully extensive. All of its potentialities are actualized. There's no like limit on reality as a whole with respect to its own laws. Its own laws are everywhere. It doesn't have to, you know, figure them out. It doesn't have to discover new laws through experience. It has it all already. So individual beings are finite and limited and have to work with limited information, but I'm not pointing to that.
Well, another example would be the map. There's a reason why the map is not the same as a city, right? When, you know, it has to be different. It has to fit in your pocket, or these days on your smartphone. No, it has to be useful for you. And so it cannot be the same as the city. In fact, it's radically different, profoundly different. So there's no reason to suppose that representations would be like reality, except
no, look at your map example more closely. I mean, why is it possible for a map to represent terrain? Because the basic properties of the map are the same. Relation between points, like the geometry of, you just scale up the geometry of the
not even
relation.
that, though. You don't have to even scale it up, because a lot of subway maps are totally not scaling up spatial relationships. They're scaling up.
That's fine, but they have the basic properties that like govern relation in space, right?
They have abstracted. They have abstracted certain, relationships, if we can call it that, right? Pattern, form. They have abstracted a certain form.
The map doesn't have it abstracted. The map has those attributes.
No, it has abstracted them, because it does not have the street. It has an abstraction of the street.
Abstraction is a mental process. Maps don't have.
Well, a map is an abstraction. Abstraction means that it does not, that it's a representation, and that it contains less information than what it represents. It filters out information.
Okay.
Obviously, the map contains vastly less information than the city.
Sure. Right. But the reason it works as a map is that the kind of information it has operates according to the same basic categories of relation that subsist in the material world. Right? It's not totally disconnected. The map.
Well, I'm not saying it's totally disconnected, but they're very different things.
I'm not saying that the mind is totally disconnected from reality. I'm saying the relation between a map and the rest of the world is kind of apt. I agree with that metaphor for the most part, and I don't think it's perfect, but the idea is that the map at its core, what does it actually consist of? A set of relations. And the nature of those relations is governed by a kind of law, geometrical law, whatever. And so is the material world. And my point is that the most fundamental
when you say that, though, you're comparing one representation to another.
Yes.
You're not comparing the map to reality, right? So you can't compare the map to reality, right?
Yeah, this is within the context of the metaphor.
Well, sure, but the point, well, you sort of jumped out of the metaphor, though. That's the point.
I took your metaphor, which is the map to the terrain. I said I agree with that. And let's map the relations. Let's map the relations, me being the map and reality being the terrain.
You said
I'm setting up a parallel metaphor to your map terrain metaphor. And in mine, it is me or you and underlying reality.
You agree that there must be some common element between them, or at least that the map must represent reality in some way that is functional for human action. Okay,
exactly.
Like with a subway, it's just the stops and the connections. So this, whatever reality is, the map is not independent of it. But that doesn't mean that reality is a map. Okay, it's not made out of paper. It doesn't have the properties of the map. It's not a flat surface. The roads are different colors, right? So you can't just say, because brains are physical objects and they have to work in the physical world, that the real world is propositional. That would be like me saying the real world consists of, like, the city consists of colored lines on a piece of paper. I mean, right? And it doesn't. So, and that was the point. That
and you're acting like it should be a logical entailment. I've never claimed that you can deduce idealism from the fact that our minds work in this way. I've never claimed that. I'm claiming that you can postulate a fundamental similarity between the underlying reality and the nature of our minds.
You're getting closer to it when you get down to the lower level, the more like common operations, right? That this is somehow getting closer to reality. I think you're saying that, or closer to some underlying level of reality. And I don't think that follows from any.
What I'm saying is that the more fundamental logical operations on which more complex, higher order operations in our minds are built are closer to the laws of physics than those high. I'm just pointing to that spectrum to start with.
But would you, yeah, okay, so my counter argument is that there's no reason to believe that, and there's actually pretty good reasons to believe that's not the case. Like, it wouldn't make sense for the universe to calculate the motion of the planets the way we calculate it. Because we can't even do it, right? We can't even calculate the motions of the planet. So obviously,
that is not the point that I made. The point that I made was that there is this spectrum in the human mind between more fundamental relations and properties and more particular high order relations and properties. They're composed of these more fundamental things. Right, there's the most basic units of mind that not like I might have a particular thing that I imagine and no other human being will imagine that particular thing, but the perceptual modalities that I'm using, the color,
yeah, like let's say space, time, causality. I mean, would those be
those things? The things we identify in our mind as the most basic components of mind are going to be more universal. That's what I said.
Well, they're universal to minds. At least to human minds. They seem to be universal to our minds, right? But how are you going beyond that? To an external realm, which is something else, which is beyond them being universal to human minds, or at least functioning brains.
Well, you can go a bunch of different ways, but one would be by an argument from analogy, basically, where you look at like what is the best way that we can describe physical systems? What is the most predictive way? And how can we hypothesize about their ontological status? And then you would point to, okay, mathematical universe hypothesis. The most accurate way we can characterize physical systems is the relation of basic quantities. And those quantities we also identify in our mind. And okay, by that analogy then.
But we have no alternative. There's no other kind of way we could think about it. Like anytime we look at a model that we come up with, obviously it's going to consist of our mental operations and our representational structures.
Okay, so, and the hypothesis is that is the structure of underlying reality. And the hypothesis is useful or not, depending on whether it gives explanatory power. But at the very least, it's answering a question.
Well, what can it explain, though? I mean, like...
Well, the status of counterfactual claims within mathematical systems.
Again, that's not something that requires an explanation. You insist on objective truth popping out of the theory. So that's your requirement.
Given your admissions, not dealing with like purely objective truth, given your admissions, we need a way that in the example, we are setting up an arbitrary set of axioms in creating a mathematical system.
I didn't say arbitrary. I didn't say that at all. You're misrepresenting.
No, okay. I'm saying you and I come together and we build a mathematical system. We come up with a set of axioms. That's why I said arbitrary, come up with them, but they have to be internally consistent. They have to work as a mathematical language. You said that there would in fact be an infinite set of true propositions which could characterize that the entailments of that system, right?
Yeah.
And the counter argument I gave was, how is it that all of those true propositions can be true? Because,
and I explained that. I gave the answer.
No, you didn't explain it, because no human mind actually can hold each of those propositions. If propositions are dependent on human minds, then you're not saying.
But that's not the sense in which they're true. I already explained it. They're true in the
infinite set. Are you saying that there's an infinite set of true propositions that would characterize the mathematical system or not? Are you saying there is that infinite set?
I mean, what do you mean by characterize? They're not going to characterize it. The axioms characterize it. You're not going to think of it by packing an infinite number of propositions into a finite brain.
I mean characterize as in describe. Like a proposition.
Well, it's not going to describe it because, again, description is finite. It's described by the axioms and the rules of inference. Those have an infinite number of possible entailments.
Of inference by themselves don't give you all of those implications of the system. You have to actually compute to get the results.
Well,
right?
they define them. You have to, if you want to know if something is true, you have to apply the system empirically to get the answer. The answer comes out of the system. So it's true relative to the system.
Okay, I know you, and you've said that many times, but when you say it's true
Right.
relative to the system, the question is, what kind of existence does this system have? Because you want to say that it doesn't exist, and yet
Well,
it
we've
does.
gone through this. I mean, it doesn't
And I
have a
don't think that
physical
it's been
existence.
satisfactorily addressed.
Well, it
This is a
doesn't have a
problem I
physical.
have with your
Well,
position, and I don't think you're
what
addressing
would count as a satisfactory answer to you?
it. Either you would have to reject the idea that there are a true set, there is an infinite set of true propositions which are true about the entailments of that system. You could reject that, and then your view would basically have to be.
What?
Why would you reject that? Because you're rejecting the existence of the system. Where
Well,
do all
I'm
those?
saying it doesn't exist as a
Where's the
physical
infinite?
object, but
I know, but what kind of existence does it have then?
well, I've already explained this several times. We
No.
create it. It exists to
Okay.
us.
If it exists in our mind, then the set of true propositions which characterize the system is not infinite. It's finite, because if it's only dependent on our minds, if that's how it subsists, the set can't be infinite. And yet it appears
No, it
that
doesn't.
the
No,
set
no, 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 no. Look, look. I can define here. I'll do it. Here's a system. We have 0, and we have the successor function of 0, which is s, and it has little parentheses, and you put something inside there, and that's the successor of whatever's inside there. So I have a rule for generating instances of the system, and I have my starting elements. This isn't an axiomatic system. It's just a language. Now I can generate there are an infinite number of possible sentences of that system. 0 is a sentence, s of 0, s of s of s of s of 0. Those are all sentences of the system. There you go.
Yeah, and it would seem that we could make claims that, like, at the nth step of this process of generating new sentences, the result would be y.
Well, that would be a statement in a different system, but sure.
Oh, I see.
mean, the result is just the result is just the application of the system, right? I can generate sentences.
I know, but the issue is, how can it be that the nth iteration of the system was true, was truly y, or not truly y, if that system doesn't have an existence outside of our mind, and our mind is finite and doesn't ever get to n? Like, if it's not countable, if we can't actually perform the mental operation, then
then
is
I
it just
can't
not
say
true?
it. Well, unless I verify it. I mean, I don't know what. Again, you're switching to a different thing, right?
No,
Because
and you're confusing your epistemic limits on truth.
You're making claims about the
truth
language. I just said here's a language that generates infinite sentences, and it fits in my head just fine. But the infinite sentences don't fit in my head.
Right.
I don't have to generate them all.
Right, and there is an infinite set of true sentences and an infinite set of false sentences.
Well, that's a whole other thing, though, right? I mean, I'm just talking about an infinite set generated from a finite set of rules. So
okay, but the idea is that the set is particular in some way. It's not an arbitrary set. It has definite properties. Each instance in the set has definite properties, and they're all deducible given the axioms of the system, right? We can know everything about that infinite set of entailments given the axioms of the system.
There's really nothing to know about it. It's just, I mean, again, now you're talking about propositions about the system, not just the sentences of it. Right? I'm just saying, look, here, it's really easy. Here's the system, generates an infinite number of sentences, fits in my head just fine. But yes, it generates an infinite number of sentences. That's it. There's no problem.
Okay, but when you're saying it generates an infinite number of sentences, potentially, you are defining a space of possible sentences, and the corollary of that is the space of impossible sentences. And how is it that there can be a true, and yeah, I am invoking the idea of propositions, because the brute fact that you could generate infinite sentences doesn't deal with the issue of the truth value of those sentences.
Well,
right?
again, I mean, okay, so
let's
just say that we use the term true. Okay, let's say we have a little more complicated language, okay? It's got S and T, or F and T. It's got F and T, and 0. So we start it with 0, and we'll just define 0 as true, let's say. And anything that has an F at the front we'll call false, and anything that has a T at the front we'll call true. Okay, and I can either put a T, I can generate an element of the set by adding a T to the front or adding an F to the front. Okay, so now I have an infinite set, and I have defined the notions of true and false with respect to that set, and the definition is finite. Right? It's not again, not an issue.
Well, no, the issue is how can those possible sentences be true if they're not in a human mind?
Well, you know,
so relative to the system,
there's a way that we can determine whether a given sentence. So if you come to me and say, I have a sentence from your language, is it true or false? I can look at it and say, oh, that's true because it starts with a T, or oh, that's false because it starts with a 0, or it starts with an F, and if it's 0, I can say it's true. So there you go. I have it. I can decide. I can give you the answer for any sentence.
Right.
I can assign to those categories.
But before you carry out the process that you need to carry out to discover the value of that entailment, and that entailment has never been spelled out. It only exists in potentia, given the axioms.
I have a rule for doing it. I don't need to have the infinite set.
That's what I'm saying. By in potentia, I mean it potentially exists given the rules that are defining the system. Given those rules, these are the true sentences, these are the false sentences. That's fine. But how do the true sentences that have never actually been instantiated yet get to be true before you actually get to them?
Well, it's defined by the rules of the system, whether or not they're true. Yeah, and if they have a T in the front, they're going to be true.
That particular entailment was never spelled out, was never written down, was never calculated.
Oh, no, I defined it. I defined it when I created the system. I said, this is true. True. We call it true if it has a T at the front, or it's a 0. And that's a finite decision process. Just look at it. Look at the first part of it, the first character. Oh,
I know, but there's nowhere in the world, like if it's an infinite set of sentences that can be generated like this, like the entire world couldn't embody the full system, even if it's
it doesn't matter. It doesn't matter, right? Don't have to embody it. I just created it.
But yeah, but given if you identify like a number of the iterations of that system, then you could search for the answer for that given number, and you can find out if it's true or false. And I'm saying that doesn't make sense if there's nowhere for that entailment of the system to actually exist prior to discovering it.
I said it exists in the rules of the system.
But then, okay, so if it exists in the rules of the system, but you reject the existence of the system and say the system only exists in our mind, you haven't answered the question.
Well, I said the system is. I mean, what I said was a little more. It was a little more involved than that. I didn't really say it exists in our mind because, again, what I said was it's not physical. So stop thinking it's physical. It's not a physical object. It's just a definition. It's an idea. So it could exist in your mind, my mind. It's like that abstract gene. It could exist in this organism, that organism.
What kind of? It seems like you're kind of giving it a semi-Platonic.
Well, I'm saying your Platonic thing is, again, it's just the set of all ideas that humans can.
I just got a call from the normal phone, and it kicked me out of this for a second. I don't know if you were replying.
Can you not hear me?
Said not first. I was interrupted on my phone.
Oh, okay. No, it's still working. I mean, we can pause and come back. It seems like we're not like making too much progress, but if you want to keep going, that's fine too.
Okay. Let's look. It's the same basic problem from the beginning. And what I said just now was, it seems like you're ascribing a kind of semi-Platonic existence, meaning just like independent existence, to systems, to definitions that we can formalize. And you're allowing, through that kind of semi-Platonic existence, for claims such as the 7,345th iteration of this system would be T versus F. You're seemingly you're allowing for those like infinite.
I'm saying this is a metaphor, right? We can invent systems that have entailments, or that we can invent languages. We can invent these things. They don't exist physically, because the language is just the form. Now you can say, well, there must be a Platonic realm in which the form exists. I mean, I don't see what that buys you. It doesn't. Again, you could just say it's that it could be contemplated by a mind. That's the nature in which it exists. That's what I would say.
As a potential mental form. Right.
Yeah. So that's your Platonic realm. It's just X is a potential mental form. That's the realm. It's defined by
potential mental forms. Then there have to be reference of those propositions. For me, a proposition.
No. I mean, they're just potential mental forms.
Yeah, okay, but I'm saying there are true and false things that we can say about those potential mental.
This is your objective truth assumption. You keep insisting on.
No, within given the system we were just talking about, you just said that arbitrary system, the one that you just invented, there is a set of possible.
I define truth.
It can go ahead.
I define truth, just like we define truth in mathematics. And our brains define a notion of truth that we use in ordinary life. Like, if I can see it, I believe it, right? And maybe I have to look at it 2 or 3 times to be really confident, but But again, it's just, there's a mental form. My brain is going to commit to using that representation. I'm going to walk around the tree instead of trying to walk through it. That's it. There's no need to believe that I'm somehow, that this mental form corresponds to another form that is somehow physically out there, or out there in some other space, or whatever. It's just that,
right.
I mean, maybe
the thing that it's allowing me to do is to make sense of how possible mental representations can be truly possible or impossible.
By truly possible or impossible
is true or false, if the proposition corresponding to it has real existence, meaning the set of.
So this is your objective truth assumption.
What?
That's your objective truth assumption. It allows you to claim that there is such a thing as objective truth, because you define objective truth as does it correspond to the real true form. The objective form, right? You assume that there are objective forms out there with objective truth or falsity conditions.
And the reason I do that is the explanatory power it gives me, which is I can think about the set of possible mental representations and address their truth values.
What I have explained.
You seem to want it both ways. You want to say that, yes, there's an infinite set of true or false propositions that come out of this mathematical system, but the mathematical system doesn't really exist. It kind of only exists in our minds, but also other minds can contain it. There's no place for the truth values.
You don't have a place either. This is a metaphor.
What is a metaphor?
You don't think the Platonic realm of forms is a place, do you?
Not a physical place.
Okay, so you don't have a place for it either then, do you?
No, I do. What is it then? It's beneath space-time. Space-time is emergent from the realm of forms.
Another metaphor, right?
Is basic relations.
So you think that reality consists of propositions.
What's that?
And why would, I mean, and this has no explanatory power. It just allows you to claim that there is a correspondence between a proposition in your head and the real counterpart. And that's all it does. I mean, it doesn't explain anything.
It gives a place where mathematical truth can exist, because you have no coherent place.
Not a place, not a place.
Come up with it. No, I know.
It's a metaphorical place.
The idea you're coming up with to say how mathematical systems exist is so nebulous. I have no idea what you're even saying, or how
no. It's no more
mathematical truth can be objective.
No,
it doesn't. What you're saying doesn't make sense.
It makes perfect sense. You just have to let go of the objective truth assumption.
That's a true propositions which characterize these arbitrary systems, and yet these systems only exist in minds. They don't have independent existence.
You keep using the word existence in different ways, and you don't claim there's an independent existence for these things either. They don't exist in space or time. They don't exist as objects. So what is this independent existence that you're talking about?
The existence is as forms, as relations. So every system, every ontology will have ontological primitives, right? There's going to be some basic thing at the foundation of your ontology, right? You could say it's atoms, that could be atomism, or you could say it's types of relations. And let's just shift. This is a more valuable discussion, maybe. What are those ontological primitives? By going with the answer that they are basic forms, we have the advantage of being able to account for mathematical structures, mathematical truth, because all of these forms are fundamental and they build on each other from the simplest to the most complex. And the end result of that realm of forms is the cosmos, which is the combination of all of these simpler, more universal forms into the more and more particular. And that is kind of the structure of reality, right? Like atoms have a kind of universal existence where it seems like they're identical everywhere in the same way. Like the basic forms are everywhere, are underlying things, and then particular locations come about through a combination of these forms. And any valid combination of forms, any set of forms that are actually held in common together are a kind of unity. There has to be that unity for it to be a coherent proposition. Propositions have a kind of unity, minds have a kind of unity, and those are the basic entities. You go from the very most basic entity, which is just unity itself. It's the most basic ontological primitive you could have. And then from unity, we have the most basic relations that come after unity, like the basic quantities. Like if these are our ontological primitives, we are able to explain why math works well in explaining the world, and rather than just like, oh, it happens to continue working, there's a much firmer foundation for why math actually works to explain the world in that conception. It also, like I said, gives us a way to account.
Math works up to the point where it doesn't work.
It's more well defined.
I mean, math doesn't work to explain the world, right?
Are well defined because we can contemplate their nature with our mind, which is of the same basic character as this underlying reality. That's the basic worldview, and it has the advantages that I've said it has.
Let's take
what's ontological primitive? Because that's the thing. The way that you account for existence.
These terms are nonsense. I don't think there's any ontology or metaphysics. I think you can theorize about your condition and come up with presuppositions of thought or a theory of the subject, and that's what people are confusing for like deep knowledge of reality, non-empirical
limitations with the theory that you're putting forward. It seems like you're building your skepticism into your ontology. That seems to be what you're doing, and you don't have to do that. You could admit skepticism, as Plato did, and at the same time posit an ontology for your theory. A theory without an ontology is a theory about what? Literally, by definition, nothing.
So what's about experience? I mean, you posit. I theorize about the external world, but I understand that those theories are representations and that reality might be different. That's the condition.
That's a weak ass theory because it doesn't say anything.
It doesn't make claims it can't back up. It makes claims that are testable, that are empirical.
The thing is, we don't know what claims will be testable.
So, I mean, like, is claiming that is a strong ass theory saying I think the world is supported by an infinite number of pink unicorns. I mean, how is that a strong theory? Whereas,
no, the point is, with conjectures, with hypotheses, we put forward hypotheses to answer the questions that we come up with, that we, like when we're theorizing about the nature of the world outside of mind. One question we might ask is, what is stuff made of? Okay, how are you going to go about answering that question
so what
unless
is
you
any answer to that going to consist of?
say again?
What is an answer to that question going to consist of?
Well, an atomist might say reality is composed of atoms, right?
Okay, so
Materialist physicist
the
today might
answer,
say it's composed of quantum fields,
okay,
right?
the
I would say
answer,
it's basic
yeah,
relations.
the answer is a representation. It's a theory.
Of course, of course.
So it's
But
never
that's
going to be, it's
theory. You're
always going to
constructing
contain
theory.
no, listen, it's always going to contain whatever is intrinsic to representation. So if logic is intrinsic to how we represent the world, then any theory is going to have to be logical. Right?
Okay, and if that's a constraint of the mind, oh well, we have to continue constructing theories.
Well, we're going to have to continue constructing theories no matter what. What else are we going to do?
Right.
But you don't have to believe
you're
that
acting
you've
like
discovered.
it's necessarily the case that the nature
I'm
of
saying
representation is not the nature of underlying reality. And my hypothesis is that actually it is the nature of underlying reality. And the reason it gives me explanatory power only comes out through the entire network of theories that I patchwork
then
together.
why doesn't mathematics work?
What's that?
Why doesn't mathematics work? Why can't we discover all of the why can't we predict the motions of the planets then?
Why can't? I mean, we can pretty well.
Only using approximations. We can't apply Newton's laws of motion. Even setting aside relativity theory, we can't use Newton's laws of motion to predict the motions of bodies in space.
Within limitation, yeah. And what that discloses then is that any finite mathematical system that we use to describe the world is going to be incomplete because math is infinite. And so there's, like, in the same way that Newtonian physics is a limiting case of relativity, like, as I forget what the condition is.
What was it? I mean, it might be a good question. Like, is Newtonian mechanics true or false? It might be a good question for you, right? Because like, there's does it correspond to a Platonic proposition that's real?
Yes, I would say any coherent set of relations.
But it's false, right? But it's a false proposition?
In the sense of correspondence. In the sense, if we're talking about does it apply to this universe, like the idea is that there are
How
many
did we come up with this false theory? And why does the false theory work?
Because it's a limiting case of the true theory, if relativity is the true theory. I'm not saying we have.
Well, it's not, relativity doesn't do it either. None of them are going to give us the answer, but
yeah,
okay. So
I said before, relativity is probably not complete because it doesn't
sure.
quantum mechanics enough.
Okay, but so the reason it works is not because it corresponds to the true form, right?
The reason that what works?
The Newton's laws of motion. The reason why we can use them in practice in a lot of applications, but not in all. And we can explain the motions of the planets, but we can't predict precisely, like the planets are fairly well spaced, so it's not a big deal, but things like the motions of asteroids are a bit harder because of the many body problem. But so why does this theory, which is false, it's not one of the true Platonic forms, and why does it work?
No. See, you interrupted what I was saying, which was answering the question in the affirmative that yes, it does exist in a Platonic realm. But you're asking
I know, but it's not one of the true ones.
No, it is one of the true ones, just not in this universe.
Well, but again, how are you say it has explanatory power. So how does it explain why that theory is effective at predicting certain things?
Because the behavior of the underlying system is described. I mean, let's say there's theory X, which is like the thing after relativity, or like 10 steps after relativity that is as true as it can possibly be about the behavior of the underlying system. The reason the approximation to that theory X works is that the behavior of that underlying system is actually governed by mathematics because it is constituted by relations.
Why didn't we jump to the correct theory immediately?
Because that's not because we don't have powerful enough intellects to do that, because we are limited in our knowledge, and we're like, okay, that's the human souls.
So we can't. But how did we get the theory? Like, what did we do to come up with a theory that is false in this universe, but works reasonably well for certain things? Like, how did that happen in your account? Like, my account is, well, we induced it from experience, and we constructed a representation, and for a while, that representation seemed adequate. In fact, it seemed like it was, true, period. There was nothing more we could do to improve it. Oh, but then we took some more observations, and
thing is that who invented Newtonian mechanics, and most of the early physicists assumed that God had made the world according to mathematical laws. That's like an ancient Pythagorean observation. That's where like Kepler got his ideas. Galileo was a Pythagorean. All the people who actually built modern physics were operating on the assumption that reality would be governed by these eternal laws.
Sure, because everybody believed that, but that's not really relevant to the question of how.
Answering the question that you asked, that's
why.
It
doesn't answer the question. I'm saying, how did we come up with it? Oh, where did it come from? How did it get into Newton's head? It wasn't just he was like, I believe in God, therefore, here is the Principia Mathematica. I mean, come on.
No, of course. I mean, it's a combination of his experience with other with obviously Galileo's model, with his contemporaries, and like part of it is, there's inspiration in mathematics. There's like someone has an idea all of a sudden, and you can't exactly define how that new idea enters in, but like we are finite beings with only limited capacities, and we luckily, through language, because language can be self-similar with this mathematical structure of underlying reality, we can inherit the valid mathematical inspirations that gave people valid insight into the models, that mathematical systems that characterize the world. But we are nevertheless limited in ourselves and our own mental powers, and don't have access to mathematical truth. We have to work for it.
Okay. So he doesn't have access to the Platonic realm of forms, so he can't compare his idea to the truth, right? Or get the truth out of this Platonic realm. All he can do is observe things and test hypotheses, come up with a theory and see if it works empirically, right? Construct it in his head using the tools that others have provided and the knowledge that others have provided, the observations that others have made and all that stuff, and work on it and try to come up with something, right?
And I would say that no, that's not all, because the way that you deal with math and logical truth is only possible if you do have access to that Platonic realm, if you do have access to those universal operations that we're all participating in, the basic operations of mathematics. You couldn't make progress on your own at all. You could make no progress unless you did have contact with that Platonic.
Well, hold on a sec, though. But so the laws of so you're saying the mathematical operations are in the Platonic realm, but so are the laws of physics, and so is whether the milk is in the fridge right now, right? But how do you explain how we have different access to those different types of propositions?
Propositions about mathematical.
Well, about the milk in the fridge, the laws of motion, and the axioms of mathematics. In your model, those all exist in the Platonic realm, right?
Yeah, I can answer that. So there's the intellect. There are different faculties of the mind, right? The intellect is the highest faculty, and that's where the mind meets the realm of forms. And that's what mathematicians have to tap into when they're at the cutting edge, when they have to find things for themselves. The intuitions, they have to rely on intuition at a certain level. Like, yeah, you formalize it and you test it and you retest it, but to the intuition that a certain form of proof is valid is intuitional, obviously. So those intuitions are accessible through the intellect, which is the top of
why are the mathematical axioms accessible, but not the laws of physics?
Because those are not as simple, right? The basic mathematical stuff is not
really
the extra baggage. The physical laws involve complex interactions, and I suspect that in any case, it's a much more complex system than pure mathematics.
Well, you can't have it both ways, right? You can't say, well, we get the mathematical axioms from this Platonic realm, and that's how we know they're true and all that. But then we have to empirically discover these other things that are also in the same realm. And I have to go to the fridge to find out if the milk is there.
Are not infinite. If we had infinite intellects, then we would
know
the realm
but
of
I'm
form.
talking about the well, obviously we agree the intellects are not infinite, but you can't explain that because in your view, on the one hand, we do have access to this realm of forms, but on the other hand, we don't have access to it, and the access is of different types or something.
Yeah, it's limited access. We access.
Okay. So are there different realms of different Platonic realms for different types of propositions?
Say again?
Are there different Platonic realms with different types of propositions in them? Like the milk is in the fridge, right? There's a proposition.
The same. Like, again, think of Max Tegmark's mathematical universe hypothesis, which is that reality.
Well, I don't know what that is, but.
Okay, well, look into it. But for now, it's just the idea that reality is basically these mathematical relations that we describe in physics. And there are simpler mathematical relations, and there are super complex mathematical relations. There are some things that we do with the intellect, which is the way that we access the intuitions of those mathematical truths. And mathematics always relies on certain intuitions that can't be fully demonstrated as valid. Like there is an element of intuition in mathematics, I think you have to leave. And then beyond that, we also have heuristic mechanisms for interfacing with the system that we're dealing with. The reality we're dealing is the reality we're dealing with is way more complicated than our intellects could process. And so we heuristically simplify that information and model it in ways that are, accessible to.
I think most people
these things.
I think most people would find the differential calculus a bit more complicated than there is milk in the fridge. And yet,
because we're simplifying with those mechanisms, and we don't know that there's milk in the fridge through intellect. It's not an intellectual operation.
Why not?
But sense perception.
Well, it requires interpretation of the sense perception, but
those
I can explain it.
Those are much longer evolved, right?
Look,
the kind of being that we are has had a lot of practice. Our souls have had much practice with that kind of learning, and we've had very little practice with direct engagement at the intellectual level.
Yeah, but that's almost argues for the opposite. It argues that we should be able to just get go directly to the Platonic realm to get the knowledge whether the milk is in the fridge, get that proposition out of there.
No, that doesn't, because whether the milk is in the fridge or not is actually way more complex than proposition.
So how do the mathematical axioms come out of the Platonic realm? How do you get access to them?
Well, I mean, they structure experience in the first place. So it's identifying the nature of the constraints on our mental operations and, kind of symbolizing them. So like counting, the example you gave with the sheep coming back in, putting the tokens down, you are like basically mapping the mental modes that you already possess.
Could that primitive shepherd have gotten the differential calculus out of the Platonic realm?
I mean, if he could live long enough to develop his soul enough to cultivate the intellect to that degree.
Yeah, see, here's my explanation. We invented mathematics. We invented the differential calculus. We invented using rocks to keep track of sheep. And so we have more access to that because we invented it, and it's the totality of it is defined by us, whereas the milk, whether the milk is in the fridge, is to some extent determined by whether my son.
Yeah, but you have no explanation for why mathematics should work other than just like, oh, it's what survived, it's what kind of, but like that doesn't answer the question. There had to be an
Well, I think
underlying.
again, it answers it in the sense that it works as much as it does, but it doesn't work in totality. We're not omniscient. Mathematics does not make us omniscient. And like I said, there are very profound limitations to our ability to use mathematics to model reality. There's a lot of approximations, assumptions, and in some cases just waving away contradictions or absurdities in things like quantum theory and even astrophysics or whatever. So our ability, like, why does mathematics work? Well, in the sense it works because it's based on very, like, the processes, very simple mental processes that are common to all humans. So anybody can learn the basics of it, at least, like identity and types. Well, I was just saying, I already gave an explanation of it. So I don't think, and it wasn't just, well, it just works.
That doesn't explain why it works, and why it works not in things.
I did explain why it works.
Like you could explain why the basic intuitions evolved if they were adaptive.
Obviously, our brains work.
Right.
Or we wouldn't be here, right? So again, that's the anthropic principle.
But why we can extrapolate out these methods as far as we can.
Because our brains work in a certain way, and then we can apply some of those methods by which our brains work outside of our brains, using beans and gourds, or using bits in a computer system, or or scratches on paper. And because those things are based on the mental processes, they produce results that we'll agree with, because every step along the way is something that corresponds to a mental process that is innate.
Not just that it doesn't produce just agreement with our mind, it also produces things in the world that would have been impossible without it, like calculating for, engineering, building buildings. Like we use math to model these things. We use it to model behavior of the stars. At every scale, we use math, like quantum systems. We use math to describe them.
Right.
And it's strikingly appropriate. There's no better way than math to describe those systems. And so it's not just that, well, it's what worked. And okay, we have the basic mental operations, but I mean, taking that seriously, if math works because we have the basic mental operations, I mean, that's really not too different from the Platonic perspective, where the intellect has access to the realm of forms, and those are already in our mind. That's why we can kind of remember these.
But I'm saying here's a better version of this that isn't that isn't like 2,300 years old, but that takes into account what we know about the brain and reality, and it takes into account 2,000 plus years of scientific discovery.
Those basic intuitions. How are those basic intuitions correspondent to the nature of the physical world?
Well, this is a question, and I've been saying this over and over, that we can't really answer because we can't compare them to the actual world. All we can do is theorize about the world using those innate abilities.
And theorize. How?
Well, no, you don't understand. All we can do is theorize about the world using our brains, so we're never going to be able to escape from the limitations of our representations. So,
and I'm saying that's the wrong epistemological position, because it leaves out the possibility of just, okay, let's build the hypothesis. The hypothesis I'm asking you to build is, how do the mental intuitions come about such that they are correspondent to reality?
But they're not correspondent to reality. They simply work.
They work. No, okay, it's semantic. how
It's
do
not
the
semantic.
mental intuitions work with the underlying reality? Why do they work? How do they work? What structural similarity is there between the world and our mental intuitions? How does that?
There is no way to answer that. That's the point.
Okay, and I have an answer. And so
And your answer is vacuous. It doesn't explain anything. It's just like saying pink unicorns did it.
and
It doesn't
I
have
think
any
that's
meaning.
ridiculous. It's not the same as saying pink unicorns did it.
Well,
It's
not
giving a basic ontology, and it can also be explicated in ways that are practical. Like, again, look at Stephen Wolfram's model, where he
Every
tries
time
to
I ask you, what does it explain?
this 3 times, and you've interrupted every time. Stephen Wolfram has a model from basic relations of like 1 point, and then like certain extremely simple laws of computation, and then he spins out. It's kind of computer based. Like, he runs these kind of iterative systems, and he's discovered through this method all sorts of known theorems in physics, in mathematics. And so, like, the implication there is that the basic structure of reality actually does mirror computation or these basic mental properties. It gives explanatory power. We can do things by building hypotheses that include this structural similarity between mental operations and physical operations. There does seem to be an analogy. And just to wave your hands and say,
no, I'm not waving my hands. I'm saying absolutely, without any doubt, there's no way. No, I'm saying absolutely, with no doubt.
I think
I'm
that is
absolutely, with zero doubt.
Advantage of taking my presupposition.
No, I'm saying we can't get outside our brains. So there is no way to compare what, like, our representation.
Saying you don't know. You don't know that there's no way to compare. No, there's no way to compare that you know of our mental representations in the underlying world. Maybe you haven't thought of other ways of testing, and you will never.
The only way to do that, that would only be possible if you erase the subject-object distinction. If we're not subjects. I mean, it's literally absurd, because we have a position from which we think and from which we interpret reality. And we can't get outside of that. We can't get outside of ourselves. That's the sense in which it's absurd, and so that's the sense in which I'm absolutely certain about it, because the alternative is absurd. Okay, now of course it doesn't get outside of absolute philosophical skepticism, but which is based on that observation, however, that we can't get outside of ourselves. So anytime you say, oh, look, our representations match reality, what you're really saying is our representations match our representations. That's all you're saying. That, oh, look, when I try to represent reality, wow, I'm representing reality.
Many times, and it's totally beside the point.
No, it's absolutely the point.
The epistemological position I'm taking is not foundationalism. It's not that we can have direct access to the underlying world. The idea is, given these limitations, there are questions that we can ask, and there are answers that we can come up with. Some answers should be derived from direct experience. Some answers we have to hypothesize on the basis of other information, kind of analogical reasoning, all sorts of different methods for coming up with hypotheses, sometimes pure inspiration. And with these hypotheses, we can theorize about the nature of that underlying reality. And of course, it will be in terms that are comprehensible in the language of our mental representations. But it doesn't mean that the underlying reality is not like that. Right. The best we can do is build the fullest theory of that underlying reality.
Well, the best we can do is not to confuse ourselves into believing. The best we can do is not to confuse ourselves into believing that we're discovering ultimate reality, when what we're really doing is theorizing about our representations of it. And discovering, there's this common element to our representations, logic.
I'm thinking about this in terms of theory, not in terms of this is a like down from on high absolute truth about the nature of the world. I'm saying the hypothesis I'm giving is that the structure of the world at a basic level is identical to the structure of our mind at a basic level. Relations, this is what the basic intuitions of our mind and the world itself have in common. That's why mathematics works, and that the existence of those mathematical forms in the Platonic realm is the way we can account for mathematical truth outside of human subjects.
Yeah, I understand your position, and it does not explain why mathematics works. And the only thing,
this explanation multiple times.
And the other thing that you seem to think it explains is the existence of objective truth, which is an assumption.
And we should be surprised that math works.
What?
That's why.
Sorry.
If the world is mathematically structured, then math will work to describe the world. That's why it works.
But I've already given examples of how the world can be structured in a way that is radically different from a theory, but the theory can still work.
That's beside the point.
No, that actually is directly
mathematical
to the point.
Approximation can still work approximately. That does not defeat the underlying example.
Radically different can work if it contains information that is sufficient to work. So yes, our representations must contain something of reality.
Yeah,
you can call that form.
What you're saying is a total non sequitur. Just because you can use the wrong math to describe a true mathematical system does not mean that system itself is not mathematical.
No. You're hold on.
Reality is mathematical in nature. Saying that you can come up with wrong math and get
you're claiming
workable answers does not disprove that in any way. There's no, what's the step in logic? What's the inference that you're actually making?
You are claiming that because we can use math to represent reality, therefore, you're claiming that the fact that, or the apparent, okay, let me phrase this differently. You're claiming that because it appears that we can represent reality using math, this is evidentiary support for the belief that reality is mathematical and that this is some underlying level of reality. I think that's what you're saying.
I mean, that wasn't what I was saying then. I was coming from the other side. What I was saying was the hypothesis of a mathematical nature to reality. It gives explanatory power to the efficacy of math.
Yeah, and I'm saying that that's not the case. And I've explained why that's not the case. It does not have explanatory power. It just doesn't explain anything. I mean, the world must
just
be
saying no doesn't do it. And I'm saying your explanation didn't work.
Claim, well, that's why I was saying your claim is here is the evidence. And then I was saying, well, here's why that's not evidence.
And I'm saying that what you said, saying it's not evidence,
there is an equal amount of evidence in the opposite direction.
Show me what evidence.
Well, I've given you examples, right? Like we can't use math to, calculate the positions of objects in space. We can use math up to the point where we can't use it. We don't have the correct laws of physics right now. We didn't have them when Newton came up with them, apparently.
That's not a counterexample. Okay, there's some level of efficacy of mathematics. That's what needs to be explained. And by saying reality is mathematical in structure, the analogical relation between the mathematical structure of reality and of our models, that analogical relation explains the partial efficacy. It does not, there's no entailment that it has to be a fully efficacious method of describing the world and that we should always have infallible knowledge. That is contained nowhere in the explanation.
But the point is that even if you believe that that the underlying reality is mathematical, which again, there's no reason to, but whatever. Even if you believe that, our models are totally different, mathematically different, radically different. Or they were, right? Like Newtonian mechanics, it may, in terms of its predictions, approach relativity theory, but in terms of the mathematics, it's actually quite different.
It's actually not. It is a subset of relativity theory. It is literally a limiting case, I think, as the speed of light approaches infinity. Then you get Newtonian mechanics out of relativity.
Well, you may be able to get it out of relativity, but the point is that, or let's even go back to something like the Ptolemaic model with epicycles, okay, which was not even, I mean, there was mathematics used to apply it, right? radically different from the later model that was used, the Copernican, Galilean, Newtonian model.
I get what you're saying.
Okay.
But how does
so
that
a radically different model can still work, right?
Okay, so an approximate mathematical model has approximate mathematical utility. A better mathematical model has better utility. That's all you're saying.
But the approximation is not a matter of degree. It's a matter of the entire form being radically different. Like the form of the Ptolemaic model is radically different from the form of the Copernican, Galilean, Keplerian, whatever model. So it's a radically different model in terms of its structure, structurally completely different. And this is like this.
It's not completely different. It's not absolutely different.
Well, it's not different every possible way, but it's using totally different calculations, and it's a totally different model. The planets are fixed in geometric solids, but they're also doing little circle-y things. And anyway,
a bad theory can be propped up with a bunch, like you said, epicycles, a bunch of kind of extra stuff to make it work. But the problem then with the theory is that it's not actually like a consistent mathematical theory where results can be derived. Like you have to add a bunch of extra caveats to make it work. And that's evidence that it's a bad mathematical structure to describe reality.
Well, fine. I mean, I'm not disagreeing with that you can, but the point is it's a structure that we use to describe reality, right? And so
and it's good to the extent it's not thoroughly mathematical.
Well, when you say mathematics works, the evidence that mathematics works is simply that we have been able to use mathematics to do certain things, right? And just like we've been able to use our brains without mathematics to do certain things. And that's it. So that's the sense in which mathematics work. And then we've reached limits too, beyond which it doesn't work.
Currently.
We can't do certain things with mathematics, or we've reached our limits. Maybe we'll go beyond them and find new limits. I don't know, but
right.
So it doesn't. Your claim that this is evidence that the underlying reality is mathematical, I think it's simply not the case. It is not evidence for it because it does not predict.
I'm going the opposite direction. I'm saying the supposition of a mathematical nature to the underlying reality gives explanatory power to the efficacy of math. And I'm saying, like, you haven't explained why we should expect math to work, except that math is derived from our mental intuitions, and our mental intuitions evolved. Like, that's the only reason.
Why should we expect our brains to work? I mean, so let's say our brains work. Is that evidence that the underlying reality of the cosmos is neurons firing? Because our brains have neurons that fire, so the reality must be neurons firing. Would that make sense? Would that be a valid inference or reasonable argument, inductive argument, that because we know brains have neurons in them and neurons fire, and we're able to do all kinds of things with brains, therefore reality must consist of neurons?
I
think you're going to say no, right? I mean, that's not reasonable, is it?
It is not reasonable, no.
Right. Because what we're doing is yes, our brains appear to work, but of course, if they didn't work, we couldn't be here having the discussion. So there's some kind of anthropic principle, which is part of the explanation. And then we can understand that, well, our brains are processing information that comes from experience. And so we're embedded in reality.
But why that works at all? Like, what's the analogical structure between reality and the brain that allows the brain to say things about reality?
Right. I'm saying this is unknowable. Because anytime we try to give the answer, anytime we try to give the answer, we're going to have to do it with a brain. So if there's some answer that we can't fit in our brain.
And I'm saying that is not relevant to formulating a hypothesis. The
Well,
hypothesis.
it is, because it means that the hypothesis is vacuous.
What?
It's vacuous because it is unknowable. Therefore, it is not empirical. There's no empirical content.
You don't know that it's unknowable. And also the criteria for how we would know whether a theory or whole worldview is right has yet to be determined.
Well,
and if that criteria is holistic, which I hold to, right, it's not any one data point that proves or disproves a theory. There's no raw data, no raw facts. It's always in the context of a holistic worldview. So how do we know that reality is mathematical in nature? It's not that you would know it in a foundationalist sense. It's the way in which your holistic model of reality works to explain philosophical problems, physical problems. Like, does it correspond to physical theories? Does it make sense of empirical data? Like, all of the possible criteria. Is it parsimonious? Does it have a kind of all of those properties? If we build a theory where math is fundamental and it's better than any competing worldview, that is a way that we could know that it's true.
Okay, so my theory is that I'm a brain in a skull, and that brain has the ability to represent reality, but that brain does not have direct access to underlying reality. All it has access to is the information of its senses, and it has innate mental abilities that it uses to construct representations of reality. And that's the limits, the intrinsic limits of subjectivity, that I can't get outside that and make claims about the ultimate nature of reality. All I can make claims about are what basically I can theorize about reality through the medium of representations, but I can never know ultimately what it is beyond theories that I construct to explain experience. That's the limit. But I can't go beyond that limit.
Mapping that into your theory in a very unnecessary way. I have that same skepticism fundamentally.
It's not
that I can't really know.
Hold on, but remember, this is an absolute certainty that I have up to the limits of philosophical skepticism. This is not something I'm just building in.
What is absolute certainty?
That I cannot escape from the condition of being a subject. So I cannot know ultimate reality directly. I can only know it from the perspective of a subject, of a brain.
Okay, what if it was the case that reality was only ever perspectives, and that you could shift through an infinite set of perspectives and know reality fully? Wouldn't that mean that you could know reality?
Well, no, because I would have, what perspectives are you talking about? I am a perspective.
Yeah, I know. And so I'm saying, if reality is fully perspectives,
I can't know it from somebody else's perspective, because that's what not I'm saying.
Imagine reincarnation or whatever. There's an infinite set of perspectives. You pass through them through time. Wouldn't that be a way fully from a subject perspective? Right?
Well, I pass through a whole bunch of perspectives. How do I know I'm passing through a whole bunch of perspectives? There'd have to be a single perspective, that then a meta perspective, right? A meta subject that partakes of all these different subjectivities, and that meta subject would be limited by whatever its constraints are.
I'm not understanding the necessity of the meta subject.
Well, you just, you said something that is sort of literally contradictory, that I could be many different subjects or perspectives.
No. Just assume that reality is only this set of perspectives, and there's a big, pretzel line that you can draw through every single perspective, and that the experience is continuous through all of them, and you fully know everything at one time.
Whose experience?
Yours.
So I'm a subject, single subject. So then how is that different from just being a single subject?
Well, because the limits of a single subject, like on Earth, is that you can never know the perspective of others. What I'm saying is that they all pretzel together, and you can get all the perspectives.
You're sure. So you're imagining that the subject is not the not tied to a single brain.
Well, I
Right?
mean, you can't know the existence of brains given your own epistemological
Well, I
limit.
theorize the exist. I can't know anything ultimately. I don't claim to
Theorize
know
the
anything
existence of
ultimately.
brains, but I don't understand why you would theorize that brains cause your subjectivity, but you wouldn't. You would say that you can't theorize about reality itself and its structure. You can
Well, I
theorize
do.
about the
No, I
sense
do
item.
theorize about reality itself. Obviously, that's what, physics is, theorizing about reality. But I don't pretend that those theories are mind independent. I know that, well, those theories are constrained by whatever theories I can possibly
And that's
come up
that's true
with.
of every theory, including yours. Like that's
Right,
just the
that's the
basic
point.
position before you even build a theory about the
Well,
nature of
that's,
the world.
yes, this is the subject, condition of being a subject, is you don't have access to absolute truth or to objective truth or anything like that. You are
No,
just,
no. It's not that you don't have access to it. It's that you don't know if you have access to it. That's what I was getting
well,
at with the
that
traveling through
that's
many
the same
subjects.
thing then, isn't it? I mean, isn't that the same thing? I mean,
No. Knowing that you don't know something and not knowing whether you know something or not are two very different things.
uh, well, what I said
Because
was I don't have direct access to objective reality.
I know, but the phrase "I don't have access," I don't have direct access—that's a truth claim that you can't really justify given
I
your own
can
perspective.
justify it, sure, I can justify it quite easily.
Not
I make
absolutely.
mistakes. I get surprised by things. I'm confused by things. Uh, I put on a different type of glasses and see the world in a different way.
Yeah, but
So
again, what if reality was only those sets of finite perspectives and you eventually went through all of them? In that sense, you would, or maybe, there was a way of terminating, just like in Platonism or Hinduism or whatever, there was a way of finally kind of ingathering all of your energies and knowing, withdrawing the object back into the subject, escaping the subject object duality, and knowing full gnosis reality itself. What if that was possible? You don't know. Maybe you have no reason to suppose that it is possible, but you don't know that it's not
well, I think
possible.
it's a meaningless concept or thought experiment that because we cannot imagine the condition of complete knowledge. It denies subjectivity. Subjectivity is all about being limited. Like the condition of being a subject is not knowing what's going on, having to figure it out, having to make decisions, having to make choices, feeling the pressure, the burden of choice with incomplete knowledge. Uh, there's no subjectivity without those things. There is no, I've made this point before that God, the notion of God as a conscious mind is absurd because a conscious mind is a decision making, it's a puzzle
And
solving, problem
that's a
solving
false inductive
device.
generalization. That's a false
Mhm.
inductive generalization. You're saying the minds that I've known have this structure of subject object duality. You don't know that knowledge
Well, I'm
can't
saying that's the
actually exist
meaning to me. I mean, that's what
fundamentally.
I would say the meaning of, I mean, these things are essential to subjectivity, I would say, that you can't really talk about a subject that knows everything because this is based on a kind of contradictory imagining. Like you're imagining God as both being like yourself, like having a problem, let's say. Could God have a problem? Could God have a desire? Could God, like, God can't have knowledge because God can't have the absence of knowledge. Knowledge is only meaningful if there's the possibility that you don't know it.
I mean, you
Like
don't you don't know that. Again, you're just kind of assuming because
I'm
mind
talking about
has
the meanings of these things. The meaning of knowledge is that it's not the thing in itself, that I have to acquire it. I learned how to ride a bike, right? I opened up the door and I found out what was behind the
in the
door.
mystic schools, they have the concept of unitive knowledge, which is a different kind of knowledge than representational or subjective
Yeah, but
knowledge.
I'm saying
But
that
anyway,
when these
let's
people
just
do
go.
these
Let's go
things,
on and finish this because I do have to go
okay,
pretty
yeah,
quick
we
here.
can wrap it up.
Here's just one. So the last thing I would just say is it seems like we're we're I'm claiming that my position, my hypothesis about the nature of um, underlying reality affords certain explanatory benefits. And it goes beyond the examples that we've looked at. We kind of got mired down in details. I claim that it has those advantages. You don't claim to explain the things that I'm claiming to explain. And on that basis alone, I would always take an explanation. If it's admittedly hypothetical, I would take a hypothesis over no hypothesis.
Can you say what I am not claiming to explain?
Why math works, why the intuitions.
Did I actually claim I couldn't explain that?
You claimed you couldn't explain why the intuitions in our mind correspond, and you didn't like the word correspond, but why they work.
I didn't say that I couldn't explain why our mental faculties work. I just don't explain again, I don't have your assumption of objective truth. And every time I explain it, you don't like the answer because it doesn't have that assumption. But that's what's going on. I'm giving the explanation. I'm saying, well, our brains evolved, they work in a certain way, they can capture some of the regularity of the world, they learn it from experience. I can give accounts of all these things. You don't like them. And the thing that you don't like is that they don't contain your assumption of objective truth.
You can go back and listen to this. Other people can listen to that section when you said that can't be answered directly in response to the question about those intuitions. You can go back and you'll recognize what I'm talking about. But anyway, so you're claiming, are you claiming that what you explain everything that I'm claiming to explain, or are you saying that there are certain things that
you're claiming to explain something which isn't an explanation? You're claiming to explain, you claim to explain in quotes why, how a mathematical theorem can be true independent of minds. And I say there's no need to, that's not something that needs an explanation. There's no problem of explanation. There's no data that require explanation. It's an assumption,
not
data.
Truth value of those things before mathematical discovery. In building an account of how mathematical discovery happens, it would be helpful if we had a way of accounting for the truth status of those mathematical claims as they were before they were actually discovered. That maybe,
but I gave that.
I don't think we
said
hit.
Mathematics is a system, and once you define the system, the theorems are defined
at length why that is problematic, because you're not accounting for how that system has its entailments or where that system is, how the system exists. So you're seemingly differentiating it from mine.
Anyway, I think go over that. It doesn't exist in physical reality.
It's incoherent. It seems that you're in contradiction with what you're saying when it comes to the treatment of mathematical systems and languages. It seems like you don't really have a good way of accounting for languages or mathematical systems. That's my perspective. But going back to the general point, I think that you are getting stuck in a kind of skepticism where you could maintain at one level the skepticism that you currently have, and at another level, you could at least try to build a theory of underlying reality. And I think you say that you have done that, but then you also say that you throw out ontology and metaphysics. And I'm saying you can't have a complete theory without ontology and metaphysics. You don't have a notion of an ontological primitive because you say, well, we can't know that. Okay, well, guess at it, and we'll see what we can derive from the guess. That's the basic difference in kind of our attitude and our approach to building hypotheses. I think mine is totally justifiable in light of like prevailing philosophy of science, the way people think about hypothetical reasoning and all of that. And I don't see why you would restrain yourself from building up certain hypotheses that you're not looking at, like the idea of an ontological primitive. What is the world actually made of? You say we can't know that. And I'm saying, okay, well, you're leaving a bunch of questions.
Well, I've explained that.
Though. Philosophical problems.
Well, I've explained that any attempt to do that is just going to be question begging. Or confusion. It's just going to be confusing yourself.
No,
so I've said, yes, let's not confuse ourselves. Let's not trick ourselves.
What the implication of the hypothesis will be. You have to first give the hypothesis, build out the system, and then predict, and then build predictions on the basis of the system. And you don't know that until you actually
why there are no
you can't a priori know that it's just going to be question begging and useless.
Yeah, like you can. Because again,
try it out.
Well, you could say that the ontological primitive is subjectivity, that I start from subjectivity. Okay, and so I try to go from there. And so I don't posit things about objectivity.
Idealism. That would be idealism. So I think
no,
what we mean.
No.
It would by definition.
No.
An ontological primitive is what is not.
Well, I don't. Well, I'm trying to use your language. I mean, I said I reject ontology, right? So, I mean, if you don't want me to I could put it in my words, or I could try to put it in your words. My point is,
You're avoiding the category of ontological thinking in the way that you're using it. You're
I'm saying I start from subjectivity.
Epistemology.
No, I start from subjectivity.
That's
So
an
I say,
epistemological vision, not an ontological.
well, it doesn't matter. You call it whatever you want. Okay? I'm saying that knowledge is constructed by a subject to explain and predict their experiences and generate action in the world. That's what I'm saying.
Yeah, and I'm saying that the question about that underlying world, it seems like you don't want to think about at a metaphysical level. Asking the question of what is it made of?
I'm saying I'm saying in my worldview, this question does not arise because it is immediately rejected as unknowable. I can say, I can say,
it's
how
unknowable.
can I best
think it's unknowable? You don't know that it's unknowable. You can reason, you can come up with likely theories which suggest that it's unknowable, but there is literally no reason not to hypothesize into what is currently thought to be unknowable territory. If people never speculated on things they thought they couldn't know, we wouldn't be here. Science wouldn't exist.
Because this is a little bit different.
I really have to go. If you want to say any
all right.
final...
Yeah, I think, well, it's fine. I think we've covered the ground or many times over, but anyway, sorry it got so contentious. I'll listen to this, but yeah, I mean, I don't think you're understanding my position, and I think I understand your position, and I think you're stuck. And I mean, go think about it. I think you're stuck on this notion of objective truth. And what would it be if you could let go of that? Could you have a worldview without objective truth? Could you do that? Could you just accept, yes, it's subjective. All I have is myself. All I can really know,
I mean, this is the same. We're restating the same problem that we were just talking about, that I was just talking about.
Yeah, but I'm saying, can you let go of that hypothetically?
Access to objective truth is one thing. Saying there is no objective truth is a really different thing. Saying there is no objective truth.
Why can't you hypothesize down?
I have access to objective truth. That's fine. I have no problem with that. But then once you admit you don't have access, then the process is building hypotheses. So anyway, we need to go. It was good talking to you. I know it got contentious. I was just trying to get my points in and not forget stuff. And we have a tendency to dance around different issues, and I tried to bring it back in. No hard feelings. We can talk again about this. But anyway, have a good rest of your day.
All right. Yeah. Have a good day. Bye.